Hello my dear students, welcome to IMS GATE Academy. I hope all of you are attending our GATE score booster sessions which are coming in the YouTube channel, right? So very good evening one and all. So in this particular session I am going to start regarding digital circuit subject. This subject is common for 4 branches: EC, electrical, instrumentation and computer science. This is one of the most important and scoring subject as per GATE exam point of view. Yes, very good evening Kundan Kumar, Abhilash, very good evening one and all. So all of you please mention to which branch you belong to. Yes, Abhilash is from CS, Dalisha is from EC. Yes, very good. See, this subject is common for 4 branches. So all of you kindly like and share this video link with all of your friends so that they also will attend this session in live, so that they also will get benefited from this session, right? Yes, very good Dharmendra, you are from electrical. Yes, very good. So we are having the students from all the branches. Yes, very good Kundan. So how many of you are attending very first time regarding our GATE score booster sessions? Whether any new student is there? Yes, Dharmendra, very good. Yeah, I am welcoming all of you for this live session. Okay, so those who are attending very first time, yeah, Dalisha is also attending very first time. So we have started our GATE score booster sessions branch wise. Okay, so you can watch those lectures which happened in the last week and this week in your free time later. Okay, yes. Yeah, so in this digital circuit subject, total we are having 7 chapters. Okay, out of which the first 5 chapters are common for all the 4 branches: EC, electrical, instrumentation and computer science. For all these 4 branches, the first 5 chapters are common, whereas 6th chapter is common for EC, electrical, IN. Whereas the last chapter, CMOS logic family, which is common for 2 branches, EC and IN. So if you observe the syllabus and the branches, the first 5 chapters are very important for all the 4 branches, right? So regarding our GATE score booster sessions regarding digital circuit subject, since it is common for 4 branches, so I have planned regarding this particular subject 3 days. Okay, so regarding chapter 1 and chapter 2, I will discuss the questions related to these 2 chapters in today's session, and on tomorrow we are going to discuss the questions related to chapter 3 and chapter 4, and day after tomorrow we will discuss the questions related to the last 3 chapters. Okay, so in these sessions, chapter wise we'll discuss the questions. Okay, these questions are very important for your coming GATE exam. So what I will do, first I will show the question, Okay, and then I will put the timer based on the level of the question. I will fix either 1 minute or 2 minutes or 3 minutes. Okay, so whatever, after you're solving the question, if you want, you can refer your notes. Okay, after solving that, whatever the answer you're getting, you can mention in the chart. Okay, and then I will start explaining each and every question, okay, one by one, right? Based on the possibility, I will discuss more than one method also, so that you will get the clarity and command over the number of concepts and number of methods also, right? So I hope all of you are eagerly waiting for the session. So all of you, please mention, are you eagerly waiting for the session? Yes. So regarding first chapter, that is number systems and codes. Yes, very good, very good. Yes. So regarding first chapter, number systems and codes. So here first we'll discuss the questions related to the number system conversions. Number system conversions. And then we'll discuss one question related to finding the base or radix. The question related to base or radix. And then we'll discuss one of the most important topic, that is data representation. So here we'll discuss the data representation. Here we'll discuss the questions related to sign magnitude form, 1's complement form, 2's complement form. And then we'll discuss the question related to the codes. Okay, so these are the topics we are going to cover now. Okay, now we'll discuss the questions related to these concepts. These concepts are very, very important as for your GATE exam. Yeah, Kundan, I think you are from CS branch. Okay, or EC, which branch you belong to? Regarding floating point representation, generally it will be covered in the computer organization. Okay, so in the next week, okay, in the next week, CO lectures also will be there, GATE score booster sessions. So during those sessions, our faculty Vijay Agarwal sir will cover. Okay, yes. So now let us start the first question. Okay, related to number system conversions. So this is the first question. This question related to MSQ. MSQ means here you're having 4 choices. Either one option or more than one option can be correct. So all of you try to verify option by option carefully. Especially when you're having MSQ, you have to verify option by option carefully whether it is correct or not. Okay. So here the question is, which of the following is or correct? They have given 4 choices. Read the statement carefully and recall the concepts related to the number system conversions. Try to solve this question. In this question, we covered all the possible number system conversions. So all of you carefully verify option by option. Some of you start with option A, some of you start with option B, some of you start with option C, some of you start with option D. Yeah, very good evening, Rupesh. Very good evening. Just now we started. This is the first question related to number system conversions. Yeah, good evening, sir. Gopal sir, good evening. Yeah, Rupesh, no issue. Whatever here I will explain, you can understand. Okay, there is no barrier regarding the language. Okay, I can understand Hindi. If you are having any doubt, Rupesh, you can post your comment in Hindi also, no issue. So here, whatever the questions we are solving, okay, I will explain. Okay, so you will get the, you can easily understand. If you are facing any issue, you can ask your query. Okay, no issue. Yeah, other students also please try. Yes, very good, Kundan. Very good. Yeah, Rupesh, in this session, we are starting the digital circuits. Regarding first chapter and second chapter, we will cover in this session. Okay, in the next session, that is on tomorrow, we will cover third chapter and fourth chapter. And day after tomorrow, we will cover the remaining 3 chapters. Okay, we just started with the number system conversions. Yes, very good, Kundan. Very good. Now we'll see option by option. Now we'll see option by option, which options are correct. See, read the question carefully. The hexadecimal equivalent of the octal number. That means the given number is octal. Read the question carefully. The hexadecimal equivalent of the octal number. That means the given number is octal. The corresponding hexadecimal is this one. The corresponding hexadecimal is this one. Whether it is correct or not, let us see. So here first they have given octal number. If you want to convert into hexadecimal, directly we cannot convert. Yeah, Rupesh. See, this is the basic concept. Okay. So, sometimes they will ask direct questions. Sometimes, you know, this number system conversion, it will be helpful in the upcoming chapters. Okay. Right. So here we are having octal number. We want to convert into hexadecimal. Okay. Direct conversion is not possible. What you have to do? First, you have to convert the given octal number into the corresponding binary. Okay. So whatever the digits, octal digits you are having, each and every octal digit, while converting into binary, how many bits you require? How many bits you require? For converting each and every octal digit into corresponding binary. Yes, very good, Abhilash. Sorry, Abhilash. Yes, very good. We require 3 bits. We have to represent each and every octal digit with 3 bits. Okay. Yes, very good, Rupesh. Very good. Now, whatever the binary number here we got, that one we can convert into the corresponding hexadecimal. We can convert into the corresponding hexadecimal by doing the groupings of 4 bits. By doing the grouping of 4 bits, we will get the corresponding hexadecimal digits. Yes, very good, Rupesh. Okay. Now, I hope all of you understood how to convert octal to hexadecimal. First, we'll convert octal to binary, and then that binary number will convert into hexadecimal. Okay. So, first I am considering the given number 155,332. 155,332. They have given octal number. Now, we have to represent each and every digit with 3 bits. 1 is nothing but 001. Next, 5 is nothing but 101. Once again 5, 101. 3 is nothing but 011. Next, 3 is nothing but 011. And 2 is nothing but 010. So this is the binary number we got, which is equivalent to the given octal number. Okay. Now, this binary number we want to convert into hexadecimal. So we have to do the grouping of 4 bits. 1010 is nothing but A. Next, 1101 is nothing but D. 1010 is nothing but A, and once again 1101 is nothing but D. So while you are doing the grouping of 4 bits, you are starting from rightmost side and then you are doing the grouping of 4 bits. Okay, here leftmost side zeros are there. Okay, these are insignificant. Even if you are neglecting, the equivalent value won't change, right? So this is the equivalent hexadecimal number for the given octal number. So that means option A is correct. Option A is correct. So here if you observe, they have given octal number. In order to convert into hexadecimal, we have converted that one into binary and then to hexadecimal. Now reverse conversion. Suppose if they have given hexadecimal, in order to convert into octal, first you will convert hexadecimal into binary. Hexadecimal into binary. Hexadecimal into binary by representing each and every hexadecimal digit with 4 bits. Okay, and then whatever the binary number you got, you have to do the grouping of 3 bits so that you will get the corresponding octal digits. Corresponding octal digits. Now we have considered one option. Okay, actually in this question they asked only octal to hexadecimal conversion, but after understanding this solution, total how many conversions we have done? With the help of option A, how many conversions you have learnt? Can you guess? I am asking total number of conversions. See, according to the given question, according to the given question, we have converted octal number into hexa. Similarly, we can convert hexadecimal back into octal. So here these are 2 conversions. Okay, but while doing this conversion, what you have learned? You have learned octal to binary and binary to octal also, right? Octal to binary and binary to octal. And in the same way, binary to hexadecimal and hexadecimal to binary, right? So total 6 conversions you have learned, right? Yeah, thank you, sir. Thank you, Gopal, sir. So here, with the help of this option A, actually the question is related to octal to hexadecimal. But with this explanation, total you have learned 6 conversions. Octal to hexa, hexa to octal, octal to binary, binary to octal, hexa to binary and binary to hexadecimal, right? I hope it is clear for everyone. Okay. So now let us proceed to the next option, whether it is correct or not. So here they are asking the decimal equivalent of the octal number. That means the given number is octal, and the corresponding decimal number they have given 143. Whether it is correct or not, let us see. Now all of you please respond. Before solving this question, say for example, if you are having here 143 is the decimal number they have given, right? So just one second. Here you are having 3 digits 143 which belongs to the decimal number system. But in general we will call this number as what? 143 or 143 like that. So what is the physical significance? How we are saying the 3 digits 143 together as 143 or 143? Any guess? Yes, very good, Kandan. Very good. Here you are having 3 digits. All the 3 digits belongs to base 10 number system. So that means each and every digit is having the respective positional weight. So since base is 10, the positional weights will be in powers of 10. 10 power 0, 10 power 1, 10 square. So what we have to do? In order to find the equivalent value, we will multiply each and every positional weight with the respective digit. Okay. We'll multiply each and every digit with the respective positional weight, and then we will add. Yeah, thank you, Ankit. So here 100 into 1 is nothing but 100, plus 10 into 4 is nothing but 40, plus 10 power 0 is nothing but 1. 1 into 3 is 3. So after finding the equivalent value, you are getting the same number. That is the beauty of the decimal number. In the decimal number system only, whenever you are having the digits like this, you can call the number together as 143 or 143 like that. This will happen only in the decimal number system, because even though after placing the positional weights, after multiplying with the respective digits and adding, you are getting the same digits whatever you have considered earlier. Okay, but whatever the approach here is there, in order to find the equivalent value, you can follow the same approach whenever you want to convert whatever may be the number belongs to whatever may be the number system. In order to find the equivalent value or in order to find the corresponding decimal, follow the same approach. Here base is 8. I want to convert this number into the decimal, or I want to find the equivalent value. Both are same. Now can you guess, here you are having 3 digits, what will be the corresponding positional weights? Yes, very good, Sandeep sir, very good. What will be the corresponding positional weights? Yes, very good, Kundan, very good. Here base is 10, that's why the positional weights are in powers of 10. In the same way, here base is 8, that means the positional weights will be in powers of 8. Now multiply the respective digit with the corresponding positional weight and then add. Okay, so 8 square is nothing but 64 into 2 plus 8 power 1 is nothing but 8 into 1 plus 8 power 0 is nothing but 1 into 7. Now 64 into 2 is nothing but 128. 8 into 1 is nothing but 8, and 1 into 7 is nothing but 7. So 128 plus 8, 136, plus 7, 143. So that means 143 is the decimal number which is equivalent to the given octal number. Yes, very good, Abhilash. So that means option B is correct. So in this question, they have asked only the octal number they have given, the corresponding decimal number they have given. Okay, we have done octal to decimal conversion. Here we have done octal to decimal conversion. Okay, now whatever the answer you got, okay, now let us verify reverse. Say for example, if you are having 143 is the decimal number if you are having. Suppose if they ask what is the corresponding octal number, how will you proceed? Yes, very good sir, very good Sandeep sir. If you are having the decimal number, if you want to convert into octal number, see, whatever may be the integer you might be having, if you are performing the division with 8, whatever may be the integer number, if you are performing division with 8, what are the possible remainders you will get in general? Yes, good evening Saurav. Yes, very good Kundan, very good. Yes, when you are dividing with 8, the possible remainders you will get 0 to 7 only. Yes, very good. 0 to 7 only you will get. Okay, so 0 to 7 belongs to, these digits belongs to octal number system, right? So that's why what we will do, we will perform repetitive division with 8. Okay, 8 ones are 8, 63 is there, 7 8s are 56, remainder is 7. I am repeating once again, here we are placing the quotient and here we are placing the remainder. Now 8 2s are 16, remainder is 1. 8 zeros are 0, remainder is 2. And here one more important thing, whatever the remainders you got, we will consider in the reverse order while you are placing the digits from left to right. Whatever the remainder you got last, that will be your starting digit while you are placing from left to right. Now the second digit is 1 and the last digit is 7. Whatever the remainder you got first, that will be your last digit. So that means here 217 is the octal number which is equivalent to the given decimal number 143. Okay, right. So here they have asked only octal to decimal, but we have done both the conversions just for understanding purpose. So here we learned octal to decimal conversion. Here we learned decimal to octal. Whatever the approach here you learned, say for example, decimal number is there. If they ask to convert into binary, what you will do? You will follow the same process with which number? If you want to convert decimal into binary, you will perform repeated division with 2, right? In the same way, you can convert decimal number into any other number system, follow the same approach, okay? And whatever may be the number system they may give, if they ask what is the equivalent value or what is the corresponding decimal number, okay, always follow the same approach. Whatever may be the number system, according to the respective basis you will get. Okay, I hope it is clear for everyone regarding this one. Yes, very good, very good. Now let us see the third option, option C. In option C, what they have mentioned, they are asking the hexadecimal equivalent of the decimal number. That means the given number is what? Decimal. The given number is decimal, and they have given the corresponding hexadecimal. They have given corresponding hexadecimal. Just now we have mentioned, just now we have seen, here you are having decimal number. In order to convert into octal, we have performed repeated division with 8, right? So in the same way, here in this case, can you guess what we will do? We will perform repeated division with which number? Yes, very good, Kundan. We will perform repeated division with 16. Here 16 ones are 16, remainder is 4, and next digit I am considering 42. 2 16s are 32, remainder is 10. Next you can consider this digit, then 16 6 are 96, remainder is 6. So when you multiply 16 with 126, you will get some number. After that you will get remainder as 6. Next 16 8's not possible, go with 7. 16 7's are 112. When you subtract 126 with 112, you will get 14. But we have to represent what? Hexadecimal is. So this 14 is nothing but what? E. 14 is nothing but E. Next, 16 zeros are 0, remainder is 7. So while doing this process, whenever you are getting quotient as 0, you can stop the process. Now, whatever the remainders you got, you have to consider in the reverse order, right? So that means the equivalent number is 7E6. But in general, in the exam, students in hurry, they will consider 6E7. Because of that, see, here also in the option they have mentioned 6E7, but that is not correct. That is not correct. Whatever the remainders you are getting, you have to consider in the reverse order, right? So that's why here option C is not correct. In the similar way, you can convert this hexadecimal into decimal by placing the positional weights in powers of 16. Is it clear for everyone regarding decimal to hexadecimal? And similarly hexadecimal to decimal if you want to convert back. Yeah, Sandeep. Yes. See, in the hexadecimal number system, base is 16. In the hexadecimal number system, base is 16. If you are having base is 16, for a single digit, the possible values that you can represent in base 16 number system is 0 to 15. But we can represent 0 to 9 only with the help of single digit. With the help of single digit, we can represent 0 to 9 only. But 10 to 15, we cannot represent with the help of single digit. That's why what we will do, we will use the alphabets. For representing 10 to 15, we will use the alphabets. A, starting with A, then B, C, D, E, F. Because these 6 values we cannot represent with the single digit, so that's why we will use the alphabets. So here we got remainder as 14, that 14 is nothing but E. Similarly, if you got 12, 12 is nothing but C, like that. Yes, very good. I hope it is clear for everyone regarding option C. Okay, so now let us proceed. The next option, option D. Here what they are asking, the equivalent base 4 number of the decimal number. That means here also they have given decimal number and the corresponding base 4 number they have given. See, you can do either decimal to base 4 or base 4 to decimal. Okay. So based on your convenience, you can proceed. So for the timing, I am converting the decimal into corresponding base 4. So here we'll perform repeated division with 4. Okay. So that you will get remainder values you will get 0 to 3. 0 to 3 belongs to base 4 digits. Okay. Now 4 6 are 24, remainder is 20. Remainder you will get 2. I am taking the next digit 0, then together 20. So 5 4s are 20, remainder is 0. Now 4 16s are 64, remainder is 1. 4 4s are 16, remainder is 0. 4 1s are 4, remainder is 0. 4 zeros are 0, remainder is 1. Now once again we'll consider remainders in the reverse order, right? So that means you will get 1 0 0 1 0. 1 0 0 1 0, the same number they have given. That means option D is correct. Option D is correct. Yes, very good Sandeep. Yes, 1 0 0 1 0. Now if you are having 1 0 0 1 0 base 4, say for example, if you want to convert into the corresponding decimal, now we will place the positional weights in powers of 4. Here 4 power 0, 4 power 1, 4 square, 4 cube, 4 power 4. See, it is very simple since you are having ones and zeros. Okay. Whenever you are multiplying 0 with anything, you will get 0. When you are adding 0 to anything, resultant value won't change. So just focus wherever ones are there, simple. And add respective positional weights. Because here when you are multiplying with 1, equivalent value will be same, right? So 4 power 4 plus 4 power 1. 4 power 4 you can write as 4 square into 4 square. That means 16 into 16, which is nothing but 256 plus 4. So which is nothing but 260. Yes, we are getting the same number, 260. Okay. So in this way you can do the conversions. Yes, very good Sandeep. So the final answer for this question is option A is correct, option B is correct, option C is wrong, option D is correct. Since this question is MSQ and since they have mentioned among the following which are correct, so the correct options are A, B and D. A, B and D. So whenever MSQ question, if you are getting in the GATE exam, so you have to choose whatever the correct options are there among the given choices, you have to choose all. Say for example, you have chosen only AB. Since D is also correct, you won't get any full marks or even you won't get any partial marking, right? So especially while you are attempting MSQ, so you have to be very careful, verify option by option, okay, whether it is correct or not according to the given question. Okay, if it is correct, you have to choose. Now, if they want to frame the same question as MCQ, can you guess what will be the framing here in the question? The same question they can frame as MCQ also. MCQ means only one option will be correct. See, instead of is or, okay, they can mention like which of the following is incorrect. If they mention incorrect, then obviously option C is incorrect. So that will be the correct option for the given question, right? So the sentence framing is very, very important. In the GATE exam, sometimes they will ask what is the equivalent or what is the correct option, like that. Sometimes they will ask what is the incorrect or not equivalent statement, etc. Right? So according to the question framing, the answer will vary. So even though you know the concept very well, but if you didn't focus the main keyword, because of that sometimes you may choose the wrong option, right? So please be careful. After solving the question, read the main keyword, what they are asking. Accordingly you can answer. Okay, right. Now with this, with the help of option A, we have learned 6 conversions, right? Now from option B, option C, option D, for generalized case what we learned, whenever you are having the decimal number, you can convert this one into any base. It could be base 2, base 4, base 8, base 16, it could be anything. And similarly, whatever may be the number belongs to any number system, we can convert into the corresponding decimal equivalent, right? So we have learned all the number system conversions with the help of first question, right? So all of you please comment Whether will all of you learned all the number system conversions with the help of this first question or not? Yes, yes. So now let us proceed to the next question. So this is the MCQ question. That means only one option will be correct. Okay. So here they have given two numbers belongs to base 6 and you have to perform subtraction operation and the equivalent value they are asking in octal form. So you have to choose the correct option. All of you try to solve. Yes, very good Kundan, very good Abhilash. All of you try this question. How many of you got after performing subtraction base 6? What is the resultant value you got in base 6? Whether anyone got up to base 6 equivalent value? Yes, very good Kundan. Yes. So here left hand side if you observe they have given two numbers. One number is 40.5, base they have given 6. Okay. Another number they have given 23.2, base 6. And you have to perform subtraction of these two numbers. But if you perform subtraction, obviously you will get base 6, but they have asked the corresponding octal. Okay, regarding that we'll discuss. Okay, right. First let us focus regarding base 6 subtraction operation. Just by looking at the number 40.5 to 3.2, obviously this number is greater, so you will get positive number only. Okay, you can perform subtraction. Now 5 minus 2 is nothing but 3. 5 minus 2 is nothing but 3. See, here 5 is the larger digit, 2 is a smaller digit. You can perform direct subtraction. Okay. Now, but 0 minus 3, can you subtract directly? No. Why? Because 0 is smaller, you want to subtract the larger from smaller, right? So that is not possible. Whenever you want to subtract smaller from larger, direct subtraction is possible. But whenever you want to subtract the larger from smaller, it is not possible. In general, what we will do? In this case, yes, thank you Vipin. Whenever we are unable to subtract the larger digit from smaller digit, that time what we will do? We will take borrow, right? So just like in the decimal number system, whenever you are taking the borrow, the equivalent value of the borrow will be how much? If you are taking the borrow in the decimal number system, equivalent value of borrow will be 10. Equivalent value of borrow will be 10 because base of the number system is 10. But here base of the number system is 6. So equivalent value of the borrow is nothing but, for generalized case, base of the number system. This is very, very important. Base of the number system. See, if you're having any doubt, just you observe the previous one. Like when you're having number belongs to any number system, what is happening? Positional weights are, what is happening? Here 4 power 0, 4 power 1. Say for example, from here if I am taking, that means the equivalent value is how much? 4 power 1, which is nothing but 4, because it is, here base value is 4, right? In the same way, for generalized case, whatever the base value you're having, when you're taking borrow from the next higher digit, the equivalent value of borrow is nothing but base of the number system. Equivalent value of borrow is nothing but base of the number system. Yes, very good, very good. So here base value is 6. So now you can add these two. 6 plus 0 is 6. Now you can perform direct subtraction, right? Because 6 is becoming larger when compared to 3. So 6 minus 3 is nothing but 3. See, up to here, most of the students in general will do correct. Okay, but from where we have taken borrow, generally students used to forget, subtract 1 from there. Okay, you should not forget from where you have taken the borrow. Okay, this is very, very important. Since I have taken borrow from here, 4 minus 1 will be 3. Now you can perform 3 minus 2, which is nothing but 13.3 base 6. 13.3 base 6. Now here you got base 6 number, but here they have asked octal number. We cannot perform directly conversion. Base 6 to base 8 we cannot directly convert. What we can do? Can you guess? First we will convert this number into which form? Yes, very good Kundan, very good Abhilash. Yes, we have to convert this base 6 into decimal number. Very good, decimal number. So here you are having what? Both integer part and fractional part. See, if you don't have fractional part, yes, very good Sandeep. If you don't have fractional part, okay, then regarding this integer part, we learned that the positional weights will be in powers of 6, 6 power 0, 6 power 1. But now, here regarding integer part we have written. Now, here right hand side what you are having? Fractional part. Now, regarding this particular digit, the corresponding positional weight will be 6 power minus 1, right? See, if you are having more digits towards this side, negatively increasing powers of base. Towards, for integer part, towards left hand side, positively increasing powers of base. For fractional part, towards right hand side, negatively increasing powers of base. Yes, very good, very good. So now follow the same approach. You already know, multiply each and every digit with the respective positional weight and then add. Okay, so 6 into 1 is nothing but 6. 6 power 0 is nothing but 1. 1 into 3 is 3 plus 6 power minus 1, I am writing it as 1 by 6 into 3. So 3 2s are 6. 6 plus 3 is 9. Then 1 by 2 is nothing but 0.5. So that means you are getting 9.5. 9.5. See, this 9.5 is the decimal number. 9.5 is the decimal number. See, if they have mentioned right hand side decimal, then option B will be correct. If they have mentioned right hand side base 6, then option A will be correct. But for this question, both are wrong. For this question, these two are wrong because they have asked the base is 8. Okay. So now this 9.5 we have to convert into octal. This 9.5 we have to convert into octal. Yes, very good Revant. Yes. Yes. Yeah. So now you are having the decimal number. If you want to convert into octal, okay. See, regarding integer part, whatever the method earlier we have discussed, same procedure. Same procedure. 9 is there. We will perform repetitive division with 8. 8 ones are 8. Remainder is 1. 8 zeros are 0. Remainder is 1. So anyway, here you are getting 2 digits. There is no confusion. Both the digits are same. Okay. So obviously you will get 1 1 which belongs to base 8. 1 1 which belongs to base 8. This is equivalent to the integer part 9. Integer part 9. Now can you guess regarding, see, if you don't have fractional part, if you are having only integer number 9, regarding that equivalent number is 1 1. But here you are having 0.5 also. Regarding 0.5, what we will do? Any guess? What is the approach? Yes, very good Kundan. Here if you observe regarding integer part, we are performing repetitive division with 8. Okay, we are considering the corresponding remainders. Now we'll follow exactly opposite procedure. That means repetitive multiplication with the corresponding base. Here 0.5 into 8, you will get 4.0. See, here while performing repetitive division, we are considering remainders. Okay, whereas here, while you are performing repetitive multiplication, whatever the integers you are getting to the left of the radix point, we will consider those integers. Say for example, in this case, you are getting 4. After taking 4, here all the digits become 0. When all the digits become 0, you can stop the process. Just like here, when you are performing repetitive division, the moment if quotient is 0, you are stopping the process. In the same way, when you are performing repetitive multiplication with the corresponding base, if all the digits become 0, you can stop the process. Or based on the given choices, after radix point, either 2 digits, 3 digits, 4 digits, based on the given choices, you can follow the number of iterations. But anyway, here we got only one integer. After that, we got all the digits are 0. Now, generally what students will do, whatever this one they got, they will directly consider. But this particular digit, we have to place after the radix point. This particular digit, we have to place after the radix point. Like this. Okay, so that means for 0.5 the equivalent octal number is 0.4. So if you combine both, then you will get 11.4. Okay, why we should not call this one as 11.4? Any reason? This number 11.4 belongs to base 8. Okay, why we should not call this number as 11.4? Just like suppose if this number is in decimal, we used to call this one as 11.4. But we should not call this one as 11.4 in base 8. Why? Yes, very good Sandeep, because here base value is 8. See, when you have placed base value 8, the equivalent value you are getting 9.5, right? That's why we should not call 11.4 here. Okay, right. So that means the correct answer for this question is option D. See, you might be having the doubt that here we have done the repetitive division, here we have done the repetitive multiplication. Why not ulta? Okay, see, the reason is very simple. Say for example, when you're having the number like this, okay, in order to find the equivalent decimal value, what we have done, focus only the integer part. Regarding integer part, positively increasing powers of base. That means what is happening? Digit after digit, what you are doing? Repetitive multiplication or repetitive division? Which operation you are performing here? See, 6 power 0, 6 power 1, 6 square, like that. Repetitive multiplication. Yes, very good Kundan, very good. Here you are performing repetitive multiplication. That's why exactly opposite procedure, repetitive division we are doing here. Okay. Similarly, here you are performing repetitive multiplication. Okay. Here if you observe 6 power minus 1, 6 power minus 2, like that. What is happening? You are doing repetitive division. That's why here opposite process, repetitive multiplication. I hope it is clear for all of you regarding overall number system conversions. All of you please respond, is it clear or not? I hope with this understanding you are not having any confusion. Whatever may be the number system they may give, you are having the confidence that to convert into any other number, right? Yes, very good Kundan. Now let us proceed to the next question. Yes, very good Abhilash. This is the NIT question. That means answer will be a number. Here they are asking the value of x plus y for all the possible values of x and y in such a way that the following equation holds. They have given one equation like this. In order to satisfy this equation, whatever the possible values of x and y you are getting, for all those possible values of x and y, just add them, and together whatever the overall number you are getting, that is the question. So all of you try this question. This is very interesting question. All of you give it a try. Yes, very good, Sandeep. So all of you give a try. All of you please share this video link with your friends so that they also will attend this session live. They also will get benefited from this session. Yes, very good, Revant, very good. Don't hesitate while you're answering in this class, because whatever answer you're getting after solving the question, please mention. Okay, sometimes you will get correct, sometimes you may get wrong, no problem. Okay, because since you are learning the subject, even if you are getting wrong, okay, later I will explain, right? So don't hesitate while answering. Yes, we'll see whether it is correct or not. Okay, so all of you please mention whatever answer you are getting, but I will keep suspense regarding this question, what is the correct answer? Because this is an interesting question, I will keep suspense, okay, for some time. See here, up to now, whatever the concepts we have discussed regarding number system conversions, those concepts now we have to apply, okay, based on the requirement. Now just observe, left hand side they have given base 4, okay, the value we know base is 4, but right hand side we don't know base value, they have mentioned y. Here base is unknown, okay. Whenever we want to equate two numbers, then obviously you should have both the numbers belongs to some equivalent number system, right? So since we don't know base of the number system here y, what we can do, let us convert both the numbers into the equivalent decimal value, right? So for that we have already discussed the procedure. Here the positional weights will be in powers of 4, and here the positional weights will be in powers of base y, y power 0, y power 1, y square. Okay, I hope up to here it is clear for everyone. Now follow the same approach, multiply each and every digit with the respective positional weight and then add. Okay, 4 cube is nothing but 64 into 1, 64, 0 into anything is 0. Then 4 into 3 is 12 plus 0 is equal to y square x plus y plus 0. Okay, now 64 plus 12 you will get 76, which is equal to y square x plus y. So this is one equation you are getting. So I am rearranging this one, y square x plus y equal to 76. You are getting one equation like this. Okay, right. Yes, very good, Sandeep. Yes, very good. Okay, you are getting this equation. Say for example, if you are considering x value like 1, 2, 3 and so on, okay, up to infinity, then accordingly when you are substituting x value 1, y square plus y equal to 76, you can solve the quadratic equation, right? You will get the roots. So accordingly you will get y roots also something up to infinity. Okay, so here you are getting x value starting from 1 up to infinity, then accordingly you will get infinite possible values regarding y. Okay, when you look at this tabular form, since you are getting infinite possible values and the question is regarding x plus y, you may come to the conclusion that resultant value of x plus y is infinite. Now can you guess whether infinite is the correct answer for this question? How many of you say infinite is the correct answer? How many of you say infinite is not the correct answer? See, our class is digital, right? Either yes or no or logic low, logic high, like that, right? Only two possible values, true or false. You can express, okay, if you are thinking this is correct, you can mention it is true. If you are thinking this is not correct, you can mention false, like that. Yes, see here infinite is not correct. Why? Even if you observe this question I have mentioned that it is a NAT. It is a NAT, right? For NAT question, you have to enter the number from your keyboard. Is it possible to enter infinite number with the help of keyboard? Obviously no, right? Even if you apply common sense, from there also you will come to know that the infinite won't be the correct answer. Won't be the correct answer. Now, in order to solve this question, the easy method is what you can do. From this, you just take common terms. Okay, y square x plus y equal to 76 we got. Y square x plus y equal to 76. This is the equation we got. Y square x plus y equal to 76. So from these two I am taking y as common. Then you will get yx plus 1 equal to 76. Now if you carefully observe, it is just like you are having two numbers. Okay, this entire yx plus 1 you can consider as a single number, right? When you are multiplying two numbers, you are getting resultant value as what? 76. Okay, so now you just write factors of 76, simple. So the first column I am considering y, the second column I am considering yx plus 1. Okay, when you consider y value 1, multiply with 76, equivalent is 76, right? Similarly for 2, 38. Similarly 3, is it possible? Not possible, okay? Because 76 by 3, you won't get integer number, right? Then go for 4, yes, it is possible, 4 19s. Okay, in this way, if you further proceed, what you will get, just you have to reverse this combination. Just one second. Just you have to reverse these combinations. 19 4, 38 2, 76 1. Okay, these are the factors of 76. I hope you learned regarding factors how to find from your basic maths, right? Okay. Now just substitute here y value 1, then x plus 1 equal to what? This entire number. Similarly here, when you substitute this one, 2x plus 1 equal 38. So like that, just substitute y value in each and every case. 4x plus 1 equal to 19. Then here 19x plus 1 equal to 4. Here 38x plus 1 equal to 2. And then here 76x plus 1 equal to 1. See, it is very simple. Whatever the y value is there, I just substituted here, and the resultant value from here, whatever I got, I just equated. Okay, right. Now from here, what are the x values you will get? X equal to 75. Now regarding here, 38 minus 1, 37 by 2. So that means x equal to 37 by 2. Similarly here, 4x equal to 18. So x equal to 18 by 4. Then here x equal to 4 minus 1 is 3 divided by 19. Here x value is 2 minus 1, that is 1 divided by 38. Now here 1 will get cancelled. From here you will get x equal to 0. X equal to 0. Now if you observe, for these four combinations you are getting x value as not an integer. Okay, x value is not an integer. Okay, see here, if you observe the question, here x value is what? It is a digit. That means in any number system, if you are having single digit, that value should be integer, right? But here it is a fraction number. Straight away you can eliminate. Yes, thank you Mayank, thank you. Yeah, now if you observe regarding x and y, integer cases, you are getting two possible values. Okay, now since you got, after eliminating this combination, we got two choices regarding x, y. Now if you are adding x plus y in both the choices, 1 plus 75 is 76, and here also 76 plus 0 is 76. So if you add both, you will get 152. How many of you say 152 is the correct answer for this question? Whether 152 is correct or not? Yes, it's not correct. The reason is, The reason is, see, from the tabular form, it may seems to be that you are getting 152, but actually not. The reason is, just observe here. In first case, what you got? You got base value 1. Here y is nothing but, just observe the previous slide. Here y is what? Base. Y is the base. Okay, just observe here. Here base value is 4. When you are having base value 4, the possible digits are ranging from 0 to 3 only. The maximum value that you can represent is 3. Similarly, in base y, if y value is 1, the maximum value you can represent is 1 only. Sorry, maximum value you can represent is 0 only, right? But here x value you got 75. In base 1 number system, it's not possible to represent 75, right? So that's why we have to eliminate that one, right? So, but here if you observe, here base value is 76. In that you can represent 0, digit value 0, right? So only this combination we have to consider. So that's why it is wrong. So 76 plus 0 equal to 76. So the final answer for this question is 76. So the very, very important formula while solving this question, whenever you are getting related to base, okay, the most important formula is whatever the base you are having. For generalized case, I am writing base or radix. If you consider R, that is always greater than the digit values. Whatever the digits we are representing, among that the maximum value of a digit. For generalized case I am talking, maximum value of a digit. But in general, all the digit values are less when compared to the base also. Okay. So that means here what is the relation we have used? Y should be greater than x. Y should be greater than x. So that is satisfying here only, but it is not satisfying here. Okay, for generalized case, this is the formula. When you are having number of digits, from there if you want to guess what will be the base starts from which digit, like that. Okay, this is the formula. Okay, so the answer for this question is 76. Final answer is 76. How many of you liked this question? How many of you felt that this is a very, very interesting question? Yes, very good. This is a very, very interesting question. If you don't apply this particular relation, okay, you may come to the conclusion that some other value as the correct, okay, but you have to always apply this kind of relation. Okay, the next question, this is MSQ, either one option or more than one option can be correct. So this is the question related to the 2's complement. All of you give it a try. Here all the numbers they have given in 2's complement form. They have given in all the choices addition operation, and they have given the equivalent. So all of you give it a try. Yes, very good, Kundan, very good. Yeah, this is also one of the interesting question which is related to 2's complement. Okay, so for the time being, I won't disclose which is the correct option, but you can respond. Okay, whatever the answer you are getting after solving, please mention in the chart. I will keep suspense for this question also. Whenever interesting question is there, I won't disclose the correct option. Okay, please have some curiosity which option or which options will be correct for some time. Yes. See here what they have given. They have given numbers in the binary form and they have just performed the addition and they have given the equivalent value. Okay, but here one important point what they have mentioned is if the following numbers, that means all these numbers are represented in 2's complement form. This is very important keyword. Whenever you are attempting any question related to 2's complement, read the question carefully. Whenever the word representation is there, that keyword plays a vital role while you are solving these questions, right? Okay, I will, before solving this question, I will write 2 statements on the board. All of you please read these 2 statements and tell me whether these 2 statements are correct or not. The first statement is 2's complement representation of a number. 2's complement representation of a number. And the second statement is 2's complement of a number. 2's complement of a number. So all of you just read these 2 sentences carefully. Don't tell that here the word representation is there, here it is not there. So because of that, both are not correct. Okay, I am not telling with respect to the English words. So I am asking with respect to the meaning. With respect to the meaning, whether these 2 statements are correct or not. All of you think twice and tell me your answer. Yeah, I will disclose which are the correct options a little later. For the time being, I am keeping suspense. So all of you please respond whether these 2 statements are correct or not. Whether both the sentences meaning wise, whether both are same or different. See, as I mentioned earlier, our class is digital, right? Either true or false. So how many of you are thinking that these 2 are same? Please respond. Both are same. Just mention in the chart same. If both are different, you can mention not same or false like that. And if it seems to be same, but at the same time, you are unable to, tell that it will be different or it will be same like that. Okay, in one sense it seems to be same, in another sense it seems to be different. Like that, if you are having in some sort of confusion or dilemma, so that also you can mention in the chart. Okay, so whatever the confusions or dilemmas are there regarding these important concepts, okay, all your confusions will be cleared off by the end of this particular session, right? Because in general, most of the students will feel that digital is the dead easy subject, because every question, if you observe most of the questions, it is in terms of ones and zeros. But when to write 1, when to write 0, where to write 1, where to write 0, that is very important, right? Based on the context, you have to answer accordingly. Okay, right. Yes, very good, Kundan and Abhilash. These 2 are not same. These 2 are not same. Okay, you will get the clarity with the help of simple example. Say for example, I am considering one number, 4-digit number like this. 4-digit number 0101. Okay, so just apply 2's complement to this number. Just apply 2's complement to this number. I hope all of you are familiar regarding 2's complement. 2's complement is nothing but 1's complement plus 1. Okay, so just complement all the bits and then add 1, which is nothing but 1011. So this is the 2's complement of this number. Okay, now say for example, if I am having this number, if I am having 4-bit number, this one. Now, if you apply 2's complement to this, once again 2's complement is nothing but 1's complement plus 1. Just complement all the bits and then add 1, which is nothing but 0, 1, 0, 1. See, I have considered one 4-bit number like this. For this number, if you apply 2's complement, you will get this one. Suppose if you are having a 4-bit number like this, if you apply 2's complement, you will get this one. Okay. Now carefully observe. Say for example, here 0, 1, 0, 1 you are having. 0, 1, 0, 1 you are having. Whenever, whatever the numbers they have given, if they mention these numbers are represented in 2's complement form, or if these numbers are signed numbers, by default the starting bit is what? Sign bit. By default the starting bit is sign bit. Okay. So whenever sign bit 0, that means what? It is a positive number. It is the positive number. Okay. Now the remaining bits will give the magnitude. Whenever sign bit 0, that means it is a positive number. The remaining bits will give the magnitude. 101 is nothing but 5. 101 is nothing but 5. Okay. So this is the sign magnitude form. This is the sign magnitude form. See, for all positive numbers, the starting bit, sign bit will be 0 and remaining bits will be giving the magnitude. Okay. So 0, 1, 0, 1 is nothing but plus 5 in sign magnitude form, 1's complement form and 2's complement form. Okay. In all the three forms, the same representation, whatever the 4-bit number you are having, the same representation is valid for positive number in all the three forms. That means what you can do, this 0, 1, 0, 1 is nothing but 2's complement representation of plus 5, right? So just carefully observe this word. Here you are having the word representation and here you are having the sign positive sign. So whenever the word representation is there and if the number is positive, sign bit should be 0. Okay. Now just observe. You are having the positive number. You have applied the 2's complement. And just by looking at the resultant number, here sign bit is 1. Sign bit 1 indicates, is it positive number or negative number? All of you please respond. Sign bit 1, is it indicating negative number or positive number? Yes, obviously it is a negative, right? Very good, Kundan. It is a negative number. Okay. Now, if you want to know what is the equivalent value of this number, see here we have taken plus 5. For plus 5, if you apply 2's complement, obviously you will get minus 5. I hope it is clear for everyone. For positive number, if you apply 2's complement, you will get negative number, right? Similarly, if you observe, the same number I have considered 1011. Okay, 1011. That is nothing but minus 5. Okay, I have applied 2's complement. What I got? I got positive number. Once again same. So that means see, among these two statements, first let us focus regarding this one. Whenever we are having positive number, if you are applying 2's complement, whenever you are having positive number, if you are applying 2's complement, you are getting negative number. Okay. Whenever you are having negative number, if you are applying 2's complement, you are getting positive number. Is it clear up to this point? All of you please respond. Just like 1's complement. For 1's complement of positive number will become negative, 1's complement of negative number will become positive. In the same way, regarding 2's complement also, positive number will become negative, negative number will become positive. Up to here, is it clear or not? Yes, I hope it is clear for everyone up to this point. Okay, there is no confusion regarding this point. Regarding this one, there is no confusion. Okay, now carefully observe. Here you are having positive number, that one we have written like this. When you apply for a positive number 2's complement, you got negative number. That means now this 1011 we can write it as 2's complement representation of minus 5. 2's complement representation of minus 5. See, just focus here. Here the word representation is there, and here sign is minus. Minus sign is there. Whenever the word representation is there, that time just focus about the sign. Here positive sign means sign bit should be 0. Negative sign means sign bit should be 1. This is the indication. This is the indication. Okay. Now you might be having the doubt that here I already discussed how the equivalent value is plus 5. Now you are having 1011. How I can write directly the equivalent value as minus 5? Okay. See, it is very simple. What you can do, just like when you're having unsigned, see, whenever they don't mention, whenever you're having binary number, if they don't mention this particular number belongs to which form in the question, by default all the numbers belongs to unsigned. Okay, when you're having unsigned, what you will do, you will place the positional weights in powers of 2. Correct? Up to here you will follow. Now, but here in this case, this particular number is a signed number. That means since sign bit is 1, obviously it indicates what? Negative number. The moment if sign bit is 0, positive number, by default for all the positive numbers, will consider anyway positional weights are positive. See, whatever the, here I have placed positional weights, here also same. Since sign bit is 0, obviously I am considering by default positive positional weights only. But whenever sign bit is 1, the corresponding positional weight should be negative. Simple. Okay. Now, since you are having 1 here, corresponding positional weight is minus 2 cube, that is nothing but minus 8, plus 0, 1, 1 is nothing but what? 3. So, which is nothing but what? Minus 5. All of you please respond. Is it clear or not? Whenever they give any number, okay, if they mention that number is already represented in 2's complement form, if you are supposed to find directly the equivalent value, okay, whenever sign bit is 0, it is easy method. Sign bit 0 means positive, remaining bits magnitude directly you can take. But whenever sign bit is 1, just you have to consider the corresponding positional weight as negative. And wherever ones are there, just add respective positional weights. Okay. So now with this understanding, now you will get the complete picture. Whenever the word representation is there, positive number, if you are having positive number, sign bit should be 0. If you are having 8 numbers, sign bit should be 1. In general, we are very much comfortable regarding positive numbers in sign magnitude form. The same representation is applicable in 1's complement, 2's complement, but we are not that much comfortable for writing negative numbers in 1's complement or 2's complement. That time what we will do, whatever the positive number you are getting, just apply complement. Okay, so that you will get the number in the corresponding negative. Okay, that's why we are going for complement method, because for writing negative number, we have to apply complement to positive number like that. Yes, very good, Revan, very good. Whenever sign bit 1 means it is an 8 number, sign bit 0 means positive number, like that. Whenever you are applying 2's complement to positive number, it will become negative. If you are applying 2's complement to negative number, it will become positive. Okay, but in the question, if they ask represent the number, but if you have applied like this, then contradictory, right? So that's why you have to be very careful while you are answering the questions related to 2's complement. Okay, right. So I hope it is clear for everyone the basic difference between these two statements, and with the help of example I have discussed. Okay, right. Now let us see option by option. Okay, for the time being, just perform by considering all these numbers in unsigned, just perform the corresponding addition. Forget about the 2's complement. For the timing, just perform by considering all the numbers belongs to binary. 0 plus 0, 0, 1 plus 1 is 2, sum is 0, carry is 1. Once again, sum is 0, carry is 1, sum is 0, carry is 1. Here 3 ones are there, is nothing but 1 1. 1 1. Next, 1 plus 1 is 2, sum is 0, carry is 1, sum is 0, carry is 1, sum is 0, carry is 1. Just by assuming all the numbers are in unsigned, just perform the normal addition. Sum is 0, carry is 1, sum is 0, carry is 1, like this. Now you are getting 4 choices like this. Okay, now if you look at all the choices, whatever the numbers here they have given. Whatever the numbers here they have given. 11, 4 zeros. 11, 4 zeros. Next, 1 followed by 4 zeros. 1 followed by 4 zeros. Then 1110. Then 410. 410, 410. Then 1 followed by 4 zeros. 1 followed by 4 zeros. So whatever the 4 choices they have given, we got exactly the same values for each and every respective option. Now tell me whether all the 4 options are correct or not. Yeah, thank you, Nikhil. Yeah, please continue attending our classes. So here we got all the 4 choices, whatever they have given, the equivalent values, we got the same thing. Now, how many of you say all the 4 options are correct for this question? See, all the 4 options will be correct provided if all the numbers are in unsigned. If all the numbers are in unsigned, by default all the 4 choices are correct. But here the very, very important keyword is this one. What they have mentioned, all these numbers are represented in 2's column form, right? So now let us see among these 4 how many really correct, how many are not correct. Let us see. Okay, for easy understanding, I will start with option D. Just tell me, here they have mentioned that these 2 numbers are represented in 2's complement form. Now just look at the sign bit and tell me whether these 2 are positive numbers or not. Obviously, because sign bit is 0, both are positive numbers. Now tell me, whenever you are performing addition of 2 positive numbers, whenever you are adding 2 positive numbers, whether you will get resultant value as negative. Yeah, thank you, Nikhil. Yeah, thank you. Whenever you are adding 2 positive numbers, whether you will get negative number. No, right? Whenever you are adding 2 positive number, obviously the resultant value should be positive. But here, what is happening? It seems to be like you are adding 2 positive numbers, but you are getting resultant value as negative, right? So what we have to do, just carefully observe. Here sign bit 0 means positive. Here sign bit 0 means positive. Up to here it is clear. Now 1010 is nothing but what? 10. 0110 is nothing but 6. So when you are adding 10 and 6, the resultant value is what? Plus 16. Plus 16, right? See, when you consider these 5 bits, when you write position bits, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. Yes, you are getting the magnitude as 16. Magnitude as 16, but now we have to consider the plus sign, right? So for plus sign, what we will do? We will place the sign bit 0. When you are adding 2 positive numbers, see, it is very simple. Just like, say for example, you are filling the bucket, okay? You are filling the water in the bucket. Say for example, you have turned on the tap, okay? So say for example, bucket capacity is 20 liter, okay? So as long as the bucket is empty, what will happen? The water will be in the bucket. Yes or no? Say for example, bucket capacity is 20 liter. As long as the bucket is empty, the water will go into the bucket only. But the moment if the capacity exceed, then what will happen? When the tap is on, even the water is coming here, but that water, what will happen? It will overflow. Yeah, thank you, sir. Vijay Garal, sir. Thank you. What is happening? It is overflowing, right? In the same way, here, when you have added 2 numbers, when you are adding 2 numbers, sometime what will happen? The resultant value we cannot accommodate with the help of the same number of bits, right? That time we have to consider the next bit also. Yes. See, just like for easy understanding, I will tell you. Say for example, 9 and 5. If you are adding, if you assume both are decimal number system, whether you can represent the resultant sum with the help of single digit? Obviously no, because here with the help of single digit, the maximum you can represent is 9 only. But since the resultant value it is exceeding 9, obviously we require one more additional digit, which is nothing but carry. Yes or no? 9 plus 5 is nothing but 14. So here in this case we are calling this is the sum digit and 1 is the carry. 1 is the carry. So this is about regarding unsigned case. In the same way you can apply here also. When you're adding two positive numbers, okay, that time whenever resultant value exceeding, okay, that time we have to consider one more bit, additional bit, okay, in order to accommodate the sign bit. Now you just observe, is there any issue? Sign bit 0 means positive number. The resultant value 1 followed by 4 zeros is nothing but 16. Yes, it's correct. Okay, but you have to place 0. But if you don't consider one more bit, same number of bits if you consider, because we cannot represent that particular plus 16 with the help of same number of bits. Okay, your answer seems to be negative. Okay, right. I hope it is clear for everyone regarding option D. Okay, now let us see other options one by one. Here 0, here just observe sign bit 1, that means it is an 8 number. Here sign bit 0, that is a positive number. 1100 is nothing but 12. Now just place the position weights, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. Since sign bit is 1, corresponding position weight is minus. Yeah, thank you very much, Nikhil. Thanks a lot. So here minus 2 power 4 is nothing but minus 16 plus 0010 is nothing but 2. So minus 16 plus 2 is nothing but minus 14. So you are adding one positive number with an 8 number, right? So minus 14 plus 12 is nothing but what? Minus 2. See, you might have studied regarding sign extension property in 2's complement form. See, just observe, whatever this number equivalent value, for this entire number equivalent value, if I consider only these two bits, then what is happening? Here sign bit is 1. The same sign bit here we have placed n number of times. Okay, this is called sign extension property. Equivalent value won't change. Okay, this entire number equivalent value, just like the way here you will perform, in the same way you can perform. Whatever the equivalent value you will get, the same number you will get just by considering these two bits also. Okay, so when you consider 1 and 0, the position weights are 2 power 0. Here sign bit is 1, that means the corresponding position weight is minus. So minus 2 power 1 is nothing but minus 2. Okay, so that means this is correct. Option C, whatever they have given, that is correct. Up to here, any confusion? All of you please respond. Whatever option D they have given, that is wrong. Option C is correct. All of you please respond. Option C is correct. Option D is wrong. So far, we have verified two options. Okay, I hope it is clear for everyone. Now let us see. Here sign bit 0, that means positive number. 1100, that is nothing but 12. Now see, this is a very, very interesting thing. Yes, very good, Revan, very good. Now here sign bit is 1. Just place the corresponding position weight. 2 power 4, since sign bit is 1, minus. So minus 2 power 4 is nothing but minus 16 plus 0100 is nothing but 4. So which is nothing but minus 12. So now all of you please respond. When you are adding plus 12 with minus 12, the resultant value should be how much? Resultant value should be how much? 0, right? Plus 12 and minus 12 is nothing but 0. Okay, but here this 1 came, but we have to ignore. See, just like, say for example, 20 liter bucket capacity is there. Okay, say for example, currently 15 liters is there in that bucket water. Okay, say for example 5 liters you have taken from that bucket. What will happen? Remaining capacity, how much is there? 10 liter water is there, other 10 liter empty is there, right? So in this case, when you are taking the water from the bucket, whether any overflow occur? In the previous example I have given, when you are having 20 liter bucket capacity, if the water is filled up to 20 liter, even after that if you are tap is on, then water is overflowing. But in this example, what I'm telling, you are having the water in the bucket, from there you are taking the water. Okay, when you are taking the water, whether any overflow will happen? In this case, we not turned on the tap. Definitely no. Okay, in the same way, here plus 12 and minus 12, when you're adding, actually you're performing subtraction. So when you're performing subtraction, you won't get any overflow. So whenever you're getting like this, please ignore that one. Okay, now when you consider only these number of bits, then yes, it is matching. It is matching, right? So here sign bit 0, that means plus sign. So anyway, for 0, whether you put plus sign or minus sign, it doesn't matter. But anyway, in general, we'll consider as 0. So if you want, you can put plus sign also, because sign bit here is 0, if you want, like that. Clear? Yeah, thank you, Pratik. Okay, so that means now from this, what you understood, whether option B is correct or not. Option B is not correct. Okay, so these are the traps. In general, in the exam, students in hurry, they will choose that, when you have performed addition like this, you will choose this one as correct. Similarly, when you perform this one, if you don't consider this 0, then you will choose this one as correct. But those are not correct, right? So you have to carefully observe. According to the question, you have to answer. Okay, right. Yes, correct, Abhilash, correct. Yeah, in 2's column representation, we are having unique representation for 0. Generally, whenever we are performing any arithmetic operation, we will consider plus 0 and minus 0 as 0 only. We don't consider plus 0 and minus 0 as two different numbers, right? So the same feature we are getting in the 2's complement. That's why we will use 2's complement when compared to other two methods, sign magnitude or 1's complement, while you are performing the subtraction operation, right? Yes. Now let us see regarding this one. So here you are adding negative number, here also both the numbers are negative. Okay, so here the position weight is minus 16 because sign bit is 1. Okay, now 1010 is nothing but 10, so which is nothing but minus 6. Now here it is minus 16 plus 6, which is nothing but minus 10. So when you are adding both net numbers, obviously the resultant value is negative only. Resultant number is negative only, minus 16. See, just now we have told sign extension property. Okay, you can apply the same logic. This entire number equivalent value is same as this number, because here sign bit is 1. The same sign bit he has placed one more time. Okay, now just observe regarding 1, the position weight is minus 16. Then 4 zeros are nothing but 0. So minus 16 plus 0 is nothing but 0. Minus 16 plus 0 is nothing but minus 16, right? Yes, we are getting the same number. So that means option A is correct. So when you consider all the numbers are unsigned, obviously all the 4 choices are correct. But since they have mentioned all these numbers are represented in 2's column form, so you have to carefully observe whether whatever the final answer you are getting, whether that is really correct or not. Okay, so after understanding the difference between 2's column representation and 2's column of a number, okay, so we are able to eliminate two options B and D. Only option A, option C are correct. Okay, so I hope you like this question. This is a very, very interesting question, right? So the correct answer for this question is option A and option C. So these two are the correct answers. So the final conclusion from this question is, it is very simple. Whenever you are adding two positive numbers, see, simple logic. Here, whenever you are adding two numbers which are represented in 2's column form, so the first and foremost important thing is just observe the sign bit. If both the sign bits are same, that means like this case or like this case you may come. Okay, that means when you are adding two positive numbers or when you are adding two negative numbers, that time overflow occurs. If any overflow occurs like this, we will consider it as a carry. Okay, so here in order to, when you are adding two positive numbers, resultant value should be positive. So that's why I have considered one more bit, that is a sign bit should be 0. Okay, similarly here, whenever you are adding two negative numbers, that time here you got 1, we will consider. But when you are adding one positive number with negative number, that time if any overflow occurs like this, we should not consider it as a carry, because actually you're performing what? Subtraction. Actually you're performing subtraction. When you're performing subtraction, there is no question of overflow. Yes or no? How many of you are agreeing to this point? Whenever you are performing subtraction, there is no question of overflow. Okay, that's why whatever the overflow here occurring, we should not consider that is the really carry, right? So we have to ignore that carry. Clear? So this is the very, very interesting question. I hope all of you got the clarity regarding this question. All of you please respond. Is it clear or not? Yes, very good, very good. So with this understanding, now let us proceed to the next question. This is the dead easy question. After understanding so much related to the 2's complement, so far whatever we have discussed, with the help of that knowledge, now you can answer this question just like that. So all of you try this question. Read the question carefully and try to attempt. Okay, this is a simple question. All of you try. Yes, correct Kundan, correct. In the previous question in option A, that is extension property. Yes, sign extension property, correct. Yes, Revant, whatever the P plus Q plus R value got, that is correct. But here in this question, they are asking the number of zeros. The number of zeros that are present in the 2's complement representation of P plus Q plus R. Yes, very good Kundan, and very good Revant. Yes, very good. See, read the question carefully. They have given three numbers: 1010, 1100, 1001, or represented. This word is very, very important when you are attempting the questions related to this particular chapter. Okay, in sign magnitude form, 1's complement form, and 2's complement form respectively. Then the corresponding decimal equivalents, will be P, Q, and R. Okay, so they have given three numbers: 1010, and they have mentioned this one is in sign magnitude, and they have given another number 1100, and they have mentioned this number is in 1's complement form. And they have given one more number 1001, and this one they have mentioned this number is already represented in 2's complement form. See, the wording is very, very important. Okay, when you're having sign magnitude form, there is no question. Here the starting bit 1 indicates sign bit. Since you're having sign bit is 1, it is negative number. Now remaining bits will give the magnitude. 0, 1, 0 is nothing but 2. So that means this is your P. They have mentioned the corresponding decimal equivalent as P. Okay, now here 1100 is already represented in 1's complement form. So just by looking at the sign bit, you will come to know it is an 8 number. But if you want to know what is the magnitude, just apply once again 1's complement to this. If you apply 1's complement to this, what you will get? You will get 0, 0, 1, 1. From here you will get the magnitude. 1, 1 is nothing but 3. 1, 1 is nothing but 3. But when you're having this number, since sign bit is 1, it is an 8 number. But regarding this value, magnitude, for magnitude you just apply 1's complement. From here we got magnitude as 3. So this is nothing but your Q according to the question. Now regarding 2's complement, I hope all of you understood from the previous question. Here sign bit is 1. The corresponding position weight is -8 since sign bit is 1. Okay, and 0, 0, 1 is nothing but 1. So that means here -8 plus 1, which is nothing but -7. So this is nothing but R. Now what they have mentioned, you are having P plus Q plus R. Just add all of them. P plus Q plus R is equal to -2 minus 3, that is -5. Once again you have to add -7. So that means you will get -12. Okay. Regarding P plus Q plus R, if they ask, the answer is -12. But in this question they have asked the number of zeros that are present in the 2's complement representation of -12, right? So that means you have to represent -12 in 2's complement form. So first you consider only the magnitude. If you are having 12, you can represent that one as 1100. This is unsigned category. Okay. Now we have to represent plus 12 in sign magnitude form. Regarding plus, the sign bit should be 0, and regarding 12, whatever the magnitude just now you got, just copy. So that means 1100. Okay, so this is 01100 is nothing but plus 12 in sign magnitude form, 1's complement form, and 2's complement form. In all the three forms, the same representation is valid for all the post numbers. Okay, for post numbers, whatever the representation you are getting in sign magnitude form, the same representation is valid in other two forms also. Now, if you apply 2's complement to this one, you will get negative number. -12. So regarding 2's complement, previously I have discussed one method, that is by adding 1 to the 1's complement. Okay, now I am discussing one more shortcut. What you have to do, you have to start from right hand side, go towards left hand side till you are getting first time 1. See, first time I am getting 1 here. Okay, so all those bits copy as it is. This is the first step. Copy all those bits as it is. Start from rightmost side and go towards left hand side till you are getting first time 1. Copy all those bits, and then remaining bits you just complement. Just do 1's complement only. Complement of 1 is 0, complement of 0 is 1. Now this 10100 is nothing but 2's complement representation of -12. 2's complement representation of -12. Okay, this is in 2's complement form. See whether your answer is correct or not. Let us verify. Here when you place the positional weights, here the corresponding positional weight is what? -16, since sign bit is 1. Now 0100 is nothing but 4. So that means -16 plus 4 is nothing but -12. Yes, we are getting the same answer. In this way you can cross check. Okay, sometime even in a hurry, okay, if you got something as the answer, whether your answer is really correct or not, you can cross verify. Okay, right. Now the question is not regarding this one. What is the question? In this particular number, how many zeros? In this particular number, how many zeros you are having? So you are having 3 zeros. So the question is the number of zeros that are present in the 2's complement representation of P plus Q plus R. So the final answer for this question is 3. I hope it is very much clear for all of you regarding the data representation, that is sign magnitude form, 1's complement form, and 2's complement form. Okay, so now let us proceed to the next question. This is MCQ question. So all of you read the question and give it a try. This is a simple question. Yeah, Kundan, which operation you have done? Whether you converted binary to gray or gray to binary? Yes, very good, Abdul. Very good. Very good, Abdul. See here, they have mentioned one particular number. Okay, you are having in terms of ones and zeros. Total number of bits are 12. And they have mentioned in this question, this particular number is represented in gray code. Okay, it is a 12-bit gray code. Okay, now they are asking the corresponding binary code. That means this question is just conversion of gray to binary. Gray to binary. Okay, so for easy understanding, first I will discuss binary to gray and then gray to binary. After that, we'll come back to this question. Okay, right. Say for example, if you are having 4 bits, okay, I am assuming these 4 bits are in binary. Now we want to convert this binary into gray code. Whatever the number of bits you are considering in binary, the same number of bits here also you will get. Okay, what we have to do, whatever the starting bit, that means leftmost bit, whatever you are having, you can copy as it is, and then you perform XOR operation on successive bits. 2 bits you take and perform exclusive operation, you will get the corresponding remaining gray code bits. Okay, so this is binary to gray code conversion. Yes. Okay, now say for example, if you are having the 4 bits which are corresponding to gray code. Yeah, no issue, Kundan. Yes. Now, if you want to convert this gray code into binary, see, whatever may be the number of bits you might be having, while you are converting from binary to gray or gray to binary, the first step is same. That means whatever the starting bit, leftmost bit you are having, you copy as it is. Here also the same logic. But here binary to gray means we will consider 2 bits and then we will perform XOR operation. Whereas gray to binary, what we will do, whatever the bit just now you got, you have to perform XOR with the next bit here. And then you will get the bit like this. Now whatever the bit you got here, you perform XOR operation with this bit, you will get like this. Now perform XOR operation with these 2 bits, you will get like this. That means first step is same, either binary to gray or gray to binary, whatever may the number of bits, the first step is same. Now the second step is, regarding binary to gray, you will perform XOR operation on successive bits, whereas here you will perform diagonally XOR operation, right? Yes, very good, Revant. Yes, very good, Abdul. Now with this understanding, now this question is regarding gray to binary. So whatever the given 12-bit is there, I have written here. Now we will copy this bit as it is, the leftmost bit we will copy as it is. Now we will perform XOR operation like this: 1 XOR 1, 0, 0 XOR 1, 1, 1 XOR 1, 0, 0 XOR 1, 1, 1 XOR 0, 1, like that. Continue further. Okay, so you have to copy the starting bit as it is and then perform XOR operation diagonally. Now the question is what? They have asked what? Whatever the binary code you are getting, you have to represent that one in hexadecimal. See, earlier one of the students asked that the number system is not part of the electrical syllabus. But if they ask the question related to gray code here, or if they frame some question in the 4th chapter regarding some circuit, if you are supposed to identify whether the circuit is acting as binary to gray or gray to binary, then definitely you should have the concept of this conversion and you should have the knowledge of number system conversion, right? See, sometimes they may not mention directly in the syllabus, but since it is a basic, you should know. Okay, so once if you are strong on the basics, whatever the level of the question they will frame in your GATE exam, you will be in a position to attempt, right? So you should not leave the basics. Okay, right. Now if you do the grouping of 4 bits, 1100 is nothing but C, you will get hexadecimal. 1101 is nothing but D, and 1010 is nothing but A. So you are getting ADC. So which is belong to hexadecimal number system. So the answer for this question is option D. Option D, ADC. Yeah, thank you, Kundan. Rupesh, are you there? I think you only asked earlier regarding number system conversion, but now you might have got how I have used that number system concept, number system conversion in the gray code, binary to gray or gray to binary, right? Yes. Rupesh, are you there? Okay, no issue. So with this, we have completed the questions related to the number system conversions and codes. Okay, so for in this particular chapter, we have discussed number system conversions. We have discussed the questions related to number system conversions. All the possible conversions we have discussed. Okay, so all of you got the confidence, I hope. And then we have discussed one question related to base or radix. And there we learned that the base value is always greater than what? Whatever the digits we are representing. Whatever the digits we are representing in that particular number system. Okay. And then we have discussed the data representation. Regarding this, we have discussed, we have seen sign magnitude form, 1's complement form and 2's complement form. Sign magnitude form, 1's complement form and 2's complement form. And we have discussed all the possible shortcuts also wherever required. And then we have discussed binary to gray and gray to binary conversion. Okay, so how many of you got the confidence after attending our session up to now regarding first chapter? How many of you got the confidence? All of you please respond before attending this session. And so far whatever we have discussed regarding first chapter, so what is your confidence level? Whether you got confidence level or not, whether is it interesting or not, whatever the questions we have discussed, all these concepts are very much useful for your coming GATE exam. Yes, thank you Abhilash, thank you Revant. Yes, very good. So with this understanding, now let us proceed further the next chapter, that is Boolean algebra and K-maps. Yeah, thank you Abhilash, thank you Revant. Yes. So in this particular chapter, we are having two main concepts. One is regarding Boolean algebra and another one is K-maps. Okay. So whenever you want to do the simplification, we will use either basic rules or laws of Boolean algebra. With the help of that, we can do the simplification, or with the help of K-maps also we can do the simplification. Okay, basic rules and then laws of Boolean algebra. And then regarding Boolean algebra, whatever the functions you are having, that representation of Boolean functions, and then we'll discuss the questions based on K-maps. Regarding minimization we'll discuss, regarding prime implicants we'll discuss. Okay, now let us solve the questions based on these concepts one by one. Okay, right. So this is the first question. This is the MCQ. Only one option will be correct. So they are asking find the complement of this expression. They have given one expression. They are asking find the complement. So all of you give a try. This is the dead easy question. Yeah, Revant, you are getting different answer which is not there in the choices. Okay. Okay, no issue. I will explain now. See, here the question is what? You have to find the complement of this entire function. Right? Yeah. Revant and Kundan are getting same answer. Okay. I will explain. Okay, you can cross check where you might have done the mistake. Okay. Right. See, for the time being, just assume, just one second. For the timing, just assume this entire function is x1 and this entire function you can assume x2. Now what you are having? You are having two terms like this x1 and x2 which are logical or together. Now we have to find the complement. So by using De Morgan's law, you will get each and every term complement. Here you are having logical or, here you will get logical and. Here logical or is there, here logical and. Suppose if you are having logical and here logical or, like that. Okay. So now if you observe here already x1, what you're having? You're having complement form. Say for example, for x, if you're already having complement, according to this formula, you're applying once again complement. So whenever you're performing 2 times complement, you will get the same function. Okay. So with this understanding, so the complement of this term, you will get the normal. That means a into, here I am directly writing, from these two I am taking a as common, then b bar plus bc. Is it clear up to this point for all of you? Please respond. It is very simple. What I have considered is this entire term is one term, one variable. This entire term is another variable. It is something like x1 plus x2. Since they have asked complement, I have applied De Morgan's law. x1 bar, x2 bar. Okay. Now, here already you are having complement. Whenever you are performing 2 times complement, you will get normal function. So under the complement, what is the function you are having? I copied as it is, but since you are having a as common, I have taken it as common. Right? Yeah, bar is okay. Yeah, sorry. Okay, that is because of typing. Okay, it is not clear. Okay, no issue. Here it is complement is there. Okay, no issue. Right. Now, regarding this second term, complement you will get. Okay. But here you are having plus sign. Now, when you apply De Morgan's law, you will get here multiplication. See, I am repeating once again, x1 bar, this term, into x2 bar, this entire term complement. Yeah, okay, Kundan, I will just write this one term and then I will wait for some time. A into b is nothing but ab plus a into b bar is nothing but ab bar. Yeah, Raven, no issue. Here you are having AB bar plus ABC whole bar. Here A into B plus AB bar. Yes, very good, Kundan, very good. Now, here, say for example, x plus yz if you are having, this one you can write it as x plus y into x plus z. Which law it is? X plus yz is nothing but x plus y into x plus z. This is which law? First one is De Morgan's law and this one is distributive law. Yes or no? This is distributive law. Distributive law, right? So now just apply the same concept here. Here A I am keeping as it is. Then just apply this concept, b bar plus b into B bar plus C, B bar plus C. Okay, now here from these two you can take A as common, then B plus B bar, and you are having overall term complement. Here B bar plus B equal to 1, here also B plus B bar equal to 1. Okay, now A into B bar plus C, B bar plus C. Next, here B plus B bar is 1, 1 into A is A bar you are getting. A into A bar is nothing but 0, 0 into anything is 0, right? So that means option D is the correct answer. Option D is the correct answer. Suppose for this overall function, if you not apply complement and if you solve, so you may get option C. But since they have asked for overall function complement, the final answer will be option D. Option D. So here you are having bar like this. Is it clear, Revant and other students? Here AB bar plus ABC whole bar, here A into B plus AB bar. For this overall function, we have to find the complement. Yes, yes, very good, Abhilash. Now let us proceed to the next question. This is the MSQ. That means either one option or more than one option will be correct. So here they have asked among the following which are correct. Which are correct. They have given one Boolean function. Here the question is regarding duality. Here the statement is regarding complement. Here the statements regarding number of literals. Regarding number of literals, they have given two choices. Obviously, since both are not same, obviously one will be correct among C and D. So all of you give it a try. These are the questions. This is the question based on the basic laws regarding duality, regarding complement, and regarding minimized function. So all of you can try. If you want, you can refer your notes. So up to now, how many, which options you got correct? Among 4 choices, up to now, whatever you tried with that, which options you got correct? Yes, Kundan, question is big, yes. At least among option C and option D, which one you got correct? At least for the timing, respond among C and D which one is correct. See, first, when you go through all the four choices, in the first choice you have to apply duality, in the second choice you have to apply complement, and in third and fourth, here they are asking regarding minimized function. Regarding in the minimized function, how many letters you are having. Okay, so whenever you are supposed to apply duality or complement, obviously the given function, first you have to do the simplify, provided if possible. If not possible, then you can follow respect to duality or respect to complement according to the question. Okay, right. Yeah, Kundan, yes, you can solve this question by using K-map, but still currently we are discussing the questions related to Boolean algebra only. So we can simplify this function with the help of one of the most important and powerful law. Can you guess? Here you are having AB plus B bar C plus AC. Without using pen and paper, you can write the simplified function of this one. So for that, we are having one of the most important and powerful law. Can you guess? From your Boolean algebra only. Yes, very good, Kundan. Consensus law. Yes, very good. See, just observe here, you are having AB plus B bar C plus AC. Here you are having three terms. Okay, for the timing I am considering this term. Just observe carefully. In this term, you are having A. That same variable A is present here, exactly same. Now, in this term, another variable C is present, exactly same it is there. Okay. Now, when you observe here you are having total three variables, A, B, C, among which two variables A and C are present. Here missing variable is what? In this third term, missing variable is what? See, just look at here you are having three variables, out of which two variables are there, right? The missing variable is what? B. B is not present in this particular term. Okay, that particular variable in this term, it is present in the normal form, and the corresponding complement version is present here. Yes, very good, Saptak. Here in this particular term, you are having two variables AC. A is present here, C is present here. Here missing variable is B, that is present in this term as normal, in this term as its complement. Say for example, if you are having A bar here, A bar can present here or A bar can present here. If you are having C here, C can present here or C can present here. Here the very important conclusion point is, whatever the term you have considered here, in that term, whatever the variables you are having, exactly same format, it should get distributed. Since you are having two variables here, A is present here, C is present here. A can present here, C can present here. There also it will applicable. Here missing variable should present. In this case, B is present normal here, B bar is present here. B can present here, B bar can present here. In all those cases, okay, whatever the logic here I have discussed, if it satisfies, now you can ignore this particular term. That is the redundant term. That is not at all required. Whatever the three terms you are having, you can simplify it to the two terms. That is nothing but AB plus B bar C. So this is nothing but by using consensus law. Regarding consensus law, is it clear or not? See, regarding any other law, regarding distributive law, De Morgan's law, you have to, remember that particular formula. But regarding consensus law, you should not remember the formula. Rather, you should remember the logic. You should remember the logic. Whenever you are having 3 terms, you can bring those 3 terms to the 2 terms. There is the possibility, provided if these 2 conditions are satisfied. If these 2 conditions are satisfied. Okay. So by using consensus law, we got AB plus B bar C. Now this is the minimized function. We cannot further simplify. Okay. Right. Now in this particular function, you are having, see, in general, variables means we always write in the normal form. In the normal form. Say for example, here you are having 3 variables A, B, C. But the variables can present in their corresponding complement version also, like A bar, B bar, C bar. So whenever you are having variable either normal form or in its complement form, for generalized case, we will call it as literal. Literal is nothing but the variable either in its normal form or in its complement form, right? So now just count how many literals you are having. In this particular function, how many literals you are having. So here literals means A, B, C are the literals. Similarly, A bar, B bar, C bar, all these are literals. Yes. Yeah, Abhilash, you can cross check. See, A is the literal, B is the literal, C is the literal. Similarly, B bar is also literal. Correct? So total you are having 4 literals. Okay, see, when you are having the function A, B, C, in general we will write in the normal form only. Variables means in the normal form only. But literal is nothing but either normal form of the variable or complement form of the variable. We will call it as literal. So total you are having 4 literals. So that means option C is correct. Option D is wrong. Option D is wrong. See, if they ask how many variables you are having, 3 variables only. But how many literals are there? Here 4. Because A, B, C are normal form, whereas B bar is in complement form. Is it clear, Abhilash? Krishna Priya, is it clear? All of you please respond regarding the number of literals in the minimized function. Why it is not 3, why it is 4. Is it clear for all of you? Yes, yes. Okay, so now we got the simplified function as AB bar, AB plus B bar C. Okay, we got the simplified function f of ABC equal to AB plus B bar C. AB plus B bar C. So in this option they are asking duality, in this option they are asking complement. Okay. Yes, very good. So now let us apply dual. Let us apply dual. See, regarding dual, I hope all of you know. Okay. See, in general, whenever you are having 2 variables, among which the basic operations that you can perform is either logical or logical AND. Whenever you are having 2 variables, among which you can perform either logical or logical AND. Okay, these are the 2 operations you can perform. Okay, so when you want to apply duality, what we will do, we will interchange them. Wherever logical AND is there, we will replace with logical OR. Wherever logical OR is there, we will replace with logical AND. Okay, and similarly, you will be having, when you are having the single bit, if you are representing a constant, either you will be having 0 or you will be having 1. So we will interchange these 2. Okay, we will interchange the binary operators and the basic binary operators. These 2 are called basic binary operators, and when you are having a bit, the possible values are 0 and 1. Okay, we will just interchange them, and the corresponding function is nothing but dual. Dual for original function. Okay, right. Now with this understanding, just carefully observe. Just apply dual. For the timing, I am labeling this one as F suffix D, where D stands for dual. So now A and B you are having, the corresponding dual is A plus B. See, you are having 2 variables A, B, I kept as it is. Regarding variables, we are not doing any modification. Only the operator we are changing. Here logical AND is there, here logical OR. Now here logical OR is there, so that means you will get logical AND. Then B bar into C, so here B bar plus C. I hope it is clear for everyone. 3 operators are there, logical AND, logical AND, logical OR, logical OR, logical OR, logical AND. Okay, now multiply A with these 2, similarly B with these 2. So A into B bar is nothing but AB bar, A into B bar plus A into C, then B into B bar is 0, then B into C, B into C. Now you got, okay, when you remove 0, because when you're adding 0, the resultant value will be same, right? Same function. So AB bar plus AC plus BC. Now all of you please respond whether we can do simplification of this function or not. Whether we can do further simplification or not. If so, by using which law? See, just now we have discussed regarding consensus law. Whenever you are having 3 terms, there is a possibility to bring 2 terms, right? See, for the timing, if you focus this particular term, here you are having AC, A is present here, C is present here. In this particular term, the missing variable is B, missing variable is B. That is present here normal form, and in its complement form is present here. So what are the 2 conditions I have told? It is satisfying. See, that particular term could be anywhere among those 3 terms, right? Yes, very good, Abhilash, very good. So in this case, this particular middle term is redundant. So the final answer will be A into B bar plus BC. By using consensus law, we are getting the 2 terms. Okay. So AB bar plus BC. Yes, it is correct. Option A is correct. Option A is correct. Okay. Now let us proceed further. The same function I have considered. Now let us find the complement. Let us apply complement to this function. So once again the same logic. Okay, just consider this entire term as x1. This entire term is like x2. x1 plus x2 whole bar is nothing but x1 bar into x2 bar. So that means the first term complement. Here logical OR is there. Here logical AND will come. And the second term complement. Okay. So here first term is nothing but AB. Second term is nothing but B bar C. Now once again you can apply De Morgan's law. AB bar is nothing but A bar plus B bar, and here B bar whole bar is nothing but B plus C bar. A bar into B, you will get A bar B plus A bar into C bar, then B bar into B is 0, then B bar into C bar. Now all of you please respond whether we can do further simplification or not. All of you please respond. Here we are having 3 terms, whether we can simplify further or not. Without using pen and paper, whether we can do further simplification or not. Just by looking at the equation, you will get the answer, right? Yes, once again, we will use the consensus law, right? So just carefully observe. If you consider here the middle term, A bar, C bar, A bar is present here, C bar is present here. Here the missing variable is B, that is present here normal form, and in its complement form is present here, right? Once again, this particular term is redundant, so you will get A bar B plus B bar C bar. B bar C bar. A bar B plus B bar C bar. Yes, A bar B plus B bar C bar. So that means option B is also correct. So for this question, 3 choices are correct: A, B and C. A, B and C. See, while doing the simplification, we have used consensus law. While performing duality also we got the requirement of consensus law. Even while performing complement also, we got the requirement of consensus law, right? So I hope all of you got the clarity regarding consensus law. Okay, the logic, 2 conditions, whatever we have discussed. Okay, if those 2 conditions are satisfied, always there is a possibility to bring 3 terms to the 2 terms. Okay, provided if those 2 conditions are satisfied, without using pen and paper, just by looking at the expression, you will get the 2 terms. Hi Devrat. So all of you please respond. I hope it is clear for everyone regarding consensus law. Among all the laws of Boolean algebra, consensus law is very, very important. Unless otherwise, you carefully observe, you won't get the, you cannot write further simplified expression, because except without using consensus law, you cannot write directly like this without using pen and paper, I am telling. Yes, I hope it is clear for everyone, right? So how many of you liked this question? How many of you felt this is a very interesting question? Yes. Now the next question is NET. Here they are asking the number of min terms present in the Boolean function. They have given one Boolean function. In that function, how many min terms you are having? That is the question. So all of you give a try. Yes, very good Devrat, very good. Others also please try. Yes, very good Krishna Priya. Very good Saptak. Yes, all of you are getting correct answer. Very good, very good. See here, there is a basic difference between min term and product term. When we can say a particular product term as min term, what is the condition? See, min term is nothing but product term only, but what is the condition? Product term or logical AND term. Logical AND term. When you are having two variables, among which if you want to perform any operation, the basic operators are logical AND or logical AND, right? So when you are performing logical AND, the resultant term is nothing but product term. Okay, in that particular term, if you are having a product term is said to be a min term. A product term is said to be a min term if if the number of literals is equal to the number of given variables, if the number of literals is equal to the number of given variables, right? See here, if you observe, you are having 4 variable function a, b, c, d, but here you are having 2 variables a, b, a, d, here b bar d, here b, c, d bar. In each and every product term, you are having number of literals is less than when compared to the total number of variables. That's why we will call these 3 terms simply product terms or logical and terms. But in order to make min term, in each and every product term, you should have 4 literals. Okay. See, for easy understanding, say for example, BCD bar, if you consider BCD bar, here you are having 3 literals, B, C, D bar. Okay. Here 1 literal is missing, so I will multiply with 1. Because A is missing, this 1 we can write it as A bar plus A. Now, this A bar you can multiply, A you can multiply. Now, just observe A bar BCD plus ABCD. Now, in this particular product term, you are having 4 literals. In this particular product term also, you are having 4 literals. Now, we will call these are the min terms, right? So, this is the conventional approach. In the same way, you have to continue further. Here, 2 literals are missing. You have to multiply 1 with 2 times. And in place of 1, you can write B plus B bar, C plus C bar regarding this one. Regarding this one, in terms of A and C, you have to write. Okay, so that is the conventional approach. Just for easy understanding, I have discussed for one case. Now, for solving this question, I will discuss the shortcut method. See, it is very simple. Okay, I will write here the given function f of ABCD, equal to AD plus B bar D plus BC into D bar. This is the given function. Okay. So, first what you have to do? Yeah, subtract. Yes, correct. You are right. D bar. A bar into BC D bar, A into BC D bar. Correct. So, here regarding min terms, what you have to do? First you write the, whenever they ask regarding min terms or max terms, write the variables order as it is. Whatever they have given variables order, you have to write exactly same. Now consider term by term. So, the first term is AD. Consider the first term. When you are writing the min terms, okay, or when you are performing the logic line, generally what is the notation we used to consider regarding min terms? Whenever you are having the variable normal form, its value is 1. Here A value is 1, D value is 1. See, when you substitute A value, D value 1, resultant value will get 1. That is the notation we have considered regarding min terms. The same notation here also will follow. Now regarding B and C, 2 bits are unknown. That means how many combinations you will get? Regarding B and C, how many combinations you will get? Yes, you will get 4 combinations, right? You just write 0, 0, 0, 1, 1, 0, 1, 1. 4 combinations regarding BC you will get. Okay. Now regarding AD you keep as it is. Sorry. Regarding AD you keep as it is. Now 1001 is nothing but 9. Next 1011 is nothing but 11. 1101 is nothing but 13. And 4 ones is nothing but 15. 9, 11, 13, 15. 4 min terms you are getting. Now regarding B bar D, B value is 0, D value is 1. Here also once again regarding AC, you will get 4 combinations: 0, 0, 0, 1, 1, 0, 1, 1. Okay. So here you are getting the min terms as 1, 3, 9, 11. So here 9 and 11 already we got. So whenever any minterm repeats, you can consider one time, because x plus x is what? X only. Okay, what are the minterms here you are getting? You have to add them. So sum of minterms form you have to represent. Next, the another one is BCD bar. BCD bar. So here B value is 1, C value is 1, D value is 0. Here A value is missing. So 1 bit unknown means you will get two possible combinations. Either it can be 0 or it can be 1. Now this is 6. This is 14. Okay, right. So here we got 4 minterms, here 2 minterms because these two already repeated, and here 2. So 4 plus 2 6, 6 plus 2 8. Total number of minterms are 8. Number of minterms equal to 8. Okay, I hope it is clear for everyone regarding this shortcut method. Yes? Okay. Now this is a very interesting question. All of you give a try. This is the MSQ question. That means either one option or more than one option can be correct. So here they are asking, they have given 4 choices. You have to identify among these 4 options which are self-dual functions. This is a very, very interesting question. All of you give a try. Some of you try for option A, option B. Some of other students try for option C and option D. So far, whatever you have done with that, so which options you got self-dual? You might have checked with at least few options, right? Either 2 options or 3 options. So far, whatever the options you have tried, among which option satisfied self-dual? Okay, how many of you know regarding self-dual? What is self-dual? See, forget about the word self. Regarding duality, just now we have discussed. In the previous questions, we have applied the duality concept. Okay, up to there you know how to apply the dual. Now, here one more word we have introduced, that is self dual. That means, say for example, whatever the given function is there, whatever the given function f, okay, for that function if you apply dual, then that one I am labeling as f suffix d, where d stands for dual, d stands for dual. Now whatever the original function you are having, after applying dual, okay, if that function, this function, if both are same, then we will call it as self dual. Okay, for a given function if you apply dual, after applying dual also, if you are getting the original function as it is, then the dual function and the original function both are same. That's why we are calling that particular function as the dual of that function is itself, in other words. Okay, in simple words we can say the dual function is nothing but the given function itself. Okay, yes, very good Abhilash. Yes, so regarding first option, you're having a bar b bar plus b bar c bar plus c bar a bar. Okay, I hope all of you might have tried regarding option A. It is very simple. Wherever logical AND is there, consider logical OR, and wherever logical OR is there, consider logical AND. Simple. This is the basic, right, regarding duality. Wherever logical AND is there, just replace with logical OR. Wherever logical OR is there, just replace with logical AND. Now here, see, if you want to do this simplification conventionally, definitely it will take more time, but I have used distributive law in one of the previous questions, right? So now just recall the distributive law. Okay, just I will write here regarding distributive law. Say for example x plus yz, I have written it as x plus y into x plus z, x plus y into x plus z. Okay, this one everyone knows regarding distributive law. This is your LHS, this is your RHS. If you are having the terms like this, you can write like this. Now if you are having the terms like this, you can write like this also, because both are equivalent, What you can do, just observe in both the terms, x plus is same, so just write as it is, x plus as it is, and then whatever you are having the other variables, just perform logical AND. Okay, so this particular RHS to LHS will applicable for variables, it will applicable for terms also. Okay, now with this understanding, say for example this b bar plus c bar, for the timing I am just writing it as c bar plus b bar, both are same. B bar plus c bar is same as c bar plus b bar. Now carefully observe, first term I will write as it is, first term I am copying as it is. Now just apply distribute law RHS to LHS here. Here c bar plus something, here also c bar plus something. Okay, so c bar plus is same in both the brackets, right? So you can copy as it is, c bar plus as it is. Now y into z we have done, written. So in the same way here b bar into a bar, that one I am writing it as a bar into b bar, both are same, because logical and logical OR, okay, will satisfy commutative law. You can interchange the variables. Now after this, just multiply a bar with these two, a bar into c bar, that is a bar c bar, plus a bar into b bar, then b bar into c bar, plus a bar into b bar. So x plus x is nothing but x only, right? A bar b bar plus a bar b bar, you will get a bar b bar only, right? So you can consider one time. So now you will get a bar, this term I am writing here, a bar b bar, this is the first term I am writing, then this term I am writing here, b bar c bar, then this term I am writing here, that is c bar plus c bar. Now just observe the given function and the dual function, whether both are same or not. A bar b bar, yes, a bar b bar, then b bar c bar, b bar c bar, c bar a bar, sorry, here it is c bar a bar. Yes, a bar into c bar is nothing but c bar a bar. Yes, we are getting the same term, c bar a bar. So that means the given function and the corresponding dual function both are same. Since the given function and the dual function both are same, it is the self dual. So that means option A is self dual. Option A is self dual. Now, let us see regarding option B. Regarding option B. A bar plus B bar into A plus B. So A bar into A is 0, so you will get A bar B plus B bar into A, you can write as A into B bar into B is 0. Okay, right. So if you observe here, A B bar plus A bar B bar plus AB is nothing but A XOR B. Now A bar B plus AB bar is nothing but A XOR B. So that means these two are not same. Okay. So option B is not self-dual, but here you got one conclusion point that XOR operation and XOR operation, when you perform among two variables, these two are dual to each other. These two are not same. These two are not same, but when you apply dual to XOR among two variables, you will get XOR. Similarly, if you apply dual to XOR among two variables, you will get XOR, like that, vice versa. Yes, very good, Abhilash, very good. Okay, so here conclusion point is XOR and XNOR among two variables are dual to each other. Okay, XOR and XNOR among two variables are dual to each other. Yes, very good, Mayank. How are you? Okay, now let us proceed for other two options, option C and option D. So, regarding option C, all of you please tell what is the dual. Yes, very good, Mayank. See, you are having A bar. So for A bar, what is the dual? Is it A? Yes, very good, Kundan, very good. It's not A. It is A bar only. Because if you recall, when you're having two variables among which the basic binary operation you can perform is either logical AND or logical OR. Okay, so whenever you're applying dual, we are interchanging those two operators. But here you're having A bar. A bar means here complement operation you are performing on a single variable. So this is the unary operator. Here complement means unary operator since you are performing on a single variable, right? So since there is no logical and logical OR, so obviously we have to keep that particular variable as it is. A bar is nothing but A bar only, right? See, if you are having, even if you observe in the previous slide, A bar, B bar, as it is we have written A bar, B bar. We haven't modified A bar as A. Okay, we kept variables as it is. Even if you observe, AB is there, we kept as it is. What we have done, wherever logical AND is there, we have replaced with logical OR. Wherever logical OR is there, we have replaced with logical AND. Okay, right. So that means for A bar, the dual is A bar. Similarly, if you are having A, the dual is A only, like that. So when you are having variable normal form or complement form, the corresponding dual will be whatever original function is there, same as it is. Okay. So option C is also example for self dual. Self dual. Yeah, Mayank. See, regarding dual in general, like say for example, in general when we are having variable A, okay, we will represent that one as its value as 1. 1 means what? We will represent in terms of electrical signal, it is a 5 volt. Okay. Suppose if you are having A bar, that means A value is 0. So that is nothing but what? 0 volt. Okay. So whatever we are discussing in general here, that is called positive logic. That means when you are having two values 0 and 1. Okay. Bit value 0, we are representing with 0 volt. Bit value 1, we are representing with 5 volt. That means the lower value we are representing with low voltage and higher value we are representing with high voltage. This is called what? Positive logic. And if you can represent ulta also, that means if you are having bit value 1, you can represent 0 volt. If you are having bit value 0, you can represent 5 volt. Now what is happening here? You are representing low value with the high voltage and high value with the low voltage. This is called what? Negative logic system. That means if you apply dual, the positive logic system will become negative logic will become positive logic. In general, whatever we are discussing in our classes, that is positive logic system. Whatever the circuits we have discussed with the help of positive logic, you can implement with the help of negative logic also. Because ultimately digital means what? We have to operate with the help of two levels only, either 0 volt or 5 volt. Okay, you can treat based on your requirement, you can consider that 5 volt as 1 or 0, like that. Okay. Now, whatever you understood so far, okay, so with that, see, some of you might have faced the difficulty regarding this function, but we can find the duality regarding this function just like that. See here, you're having XOR among three variables. So for the timing, I am representing like this. We can perform XOR on two variables and then with the third variable, right? Okay. Now just recall whatever the conclusion point from this we have discussed. Whenever you're having two variables among which XNOR or XOR, if you apply dual of XOR will become XNOR, dual of XNOR become XOR, vice versa, right? So with this understanding, now we can solve the option D just like that. Yeah, thank you, Amit. Now we want to say, for example, you can label this A XOR B as something like P. Okay, P XOR C, say for example. Okay, now just apply dual to this one. Just we have to apply dual to this one. Okay, so if you are having P XOR C dual means you are having two variables among which XOR operation, that means what you will get? XNOR. Okay, but P is nothing but what? A XOR B. So for A XOR B, what you will get? For A XOR B dual is what? A XOR B. So just substitute this one here, because initially you are having P, but for the entire expression we are applying dual. So that means you should get P dual, right? So P is nothing but A XOR B. A XOR B dual is nothing but A XOR B. I hope up to this point it is clear. It is very simple. Whatever the given function is there, I have performed XOR on two variables and then with third variable. Okay. For easy understanding, I am assumed this entire thing as one variable. When you are having two variables, dual of XOR is nothing but XNOR. Similarly, where P is nothing but A XOR B dual is A XNOR B. Now with this understanding, just substitute entire thing here. So what you will get regarding the given function dual will be what? FD of ABC, which is nothing but, first you are having A XNOR B. Just carefully observe this one and you can apply dual. Regarding A XOR B, you are getting A XNOR B. That entire thing is like single variable. Now, you are having XOR with C. That means here you will get XNOR with C. All of you please respond up to this one. Up to this point, is it clear or not? For understanding purpose, I have written these two sentences. But directly from this equation, you can write this one. Clear? Right. Now, see, you might have, generally students will write this entire function as like this. But this is not correct. See, when you are having three variables among which if you are performing XOR, it is as good as you can perform XOR on two variables, any two variables first and then with third variable. But here you are performing XOR among two variables and then with third variable. This is not equal to if you are performing XOR operation among three variables directly. Okay, why it is or how it is, I will show. See, why these two are not equal, I will show. So here you are having A XOR B and then XOR with C. Say for example, if you are having x exclusion or y, which is nothing but x bar y bar plus xy. I hope all of you are know about this particular XNOR expression among two variables. Okay. Now here you are having a XNOR b. Okay. So first I am considering a XNOR b. A XNOR b. Okay. Or otherwise I will just one second. You can assume this entire variable as q. Say for example q XNOR c you want to perform q XNOR c. So that is nothing but q bar c bar plus qc. Okay, I have considered q and c. XNOR is nothing but q bar c bar plus qc, right? Yeah, thank you Rakesh sir, thank you. Now where q is nothing but what? A XNOR b. Where q is nothing but a XNOR b. Q is nothing but a XNOR b. Now in the place of q, if you write a XNOR b, a XNOR b, here you are having complement, here c variable complement, then here q as it is a XNOR b and then c. I hope it is clear for everyone up to this point. Okay. Now complement of XNOR is nothing but XOR. Complement of XNOR is nothing but XOR. Then c bar. Here XNOR you are having, you can write it as complement of XOR. Complement of XOR is nothing but XNOR. Now just observe. It is like x bar y plus xy bar. X bar y plus xy bar, which is nothing but what? X exclusive or y, where x is nothing but this entire function a XOR b, XOR with c. So this is same as a XOR b XOR c. Okay. So whenever you want to perform XNOR operation among two variables and then with third variable, okay, any two variables you can perform first and then with third variable. After doing that, you will get among three variables directly XOR function, but not XNOR function among three variables. See, XNOR function among three variables is nothing but what? Complement of XOR. Complement of XOR. But here, if you observe, what you are getting? You are getting XOR operation among three variables. Okay. So here originally what we have considered XOR function among three variables. After applying dual also we are getting the same function. So that means option D is also self-dual. Option D is also self-dual. Okay. So for this question option A we got self-dual, option B is not, option C is self-dual and option D is self-dual. Okay. So I hope all of you got the clarity regarding self-dual function. Now the next question, up to now we have discussed the questions related to Boolean algebra. Now we are going to discuss the questions related to K-maps. So this is the question MCQ, that means only one option will be correct. So read the question carefully. Here they are asking incorrect. So whenever MCQ or MSQ questions are there, read the question carefully. Okay. Based on the context, the answer will vary. Okay. So all of you read the question carefully. Sometimes they will ask correct or equivalent. Sometimes they will ask incorrect or not equivalent. So according to the question sentence framing, you have to answer. Okay. Yeah, Kundan. A, B, C are the correct statements. Yes, very good. But here the question is incorrect statement. That means option D will be the correct. Okay. So based on the context, you have to answer. Okay. Right. So they have given one Boolean function f of ABC equal to sigma m 1236. 1236. Since it is a 3 variable function, you have to draw the 3 variable K-map. Now here variables are ABC. So whenever they give function in terms of minterm, sum of minterms, what you have to do, the first step is you have to place the respective ones in the minterm positions. Okay. So ones in the respective minterm positions. So 0, 1, 2, 3, 1, 2, 3, then 4, 5, 6, 4, 5, 6, 7. Okay. 0, 1, 2, 3, 4, 5, 6, 7. I know all of you how to place the ones in the respective minterm positions. Okay. So now, whenever, especially the question related to the prime implicants, what you have to do, since it is a 3 variable function, you have to start with whether grouping of 2 power 3 adjacently placed ones, is it possible or not? You have to check. Here it is not possible, then go for 2 square. Okay, grouping of 4 adjacently placed ones. Here you are having total 4 ones, but all the 4 ones are not together adjacently placed. Then go for 2 power 1. So here grouping of 2 power 1, that means grouping of 2 adjacently placed ones possible. So do all such groupings. Do all such groupings. Here you can do the grouping of these 2 ones, and you can do grouping of these 2 ones, and you can do the grouping of these 2 ones. So for this given K-map, there are 3 possible groupings, grouping of adjacently placed ones. Okay. So you have to do all the possible grouping of adjacently placed ones in decreasing powers of 2. In decreasing powers of 2. Why we are doing decreasing powers of 2? Because ultimate aim is what? We want to get the minimized function. Okay. So regarding this one, row wise A value is 0, that means A bar. Column wise C value is 1, that means C. A bar C. Next, regarding this column, here B value is 1, C value is 0, that means B into C bar. B into C bar. Now coming to this grouping, row wise A value is 0, A bar. Column wise, here, just 1 second. Column wise B value is 1, that means A bar B. Okay. So here we have done the groupings in decreasing powers of 2 adjacently placed ones. Okay. After that, whatever the product terms you are getting, we will call all these product terms initially them as prime implicants. Initially, after doing all these groupings like this, whatever the product terms you are getting, we will call them as prime implicant initially. Okay. We will call initially all of them as prime implicant. Now, there is the difference between prime implicant and essential prime implicant. Okay. See, say for example, if you consider this particular grouping, here you are having 2 ones. Okay. For suppose, if you don't do this grouping, this one was covered by some other grouping, but whether this particular one was covered by any other grouping? Is there any other grouping for this particular one if you don't do this particular grouping? No, right? So that means this particular grouping is what? Compulsory grouping. So that means it is essential prime implicant. Whenever that, whatever the grouping you have considered, in that grouping, if at least single one, if it except that particular grouping, if there is no other grouping, that means that particular grouping is mandatory. So then we will rename that particular prime implicant as essential. Essential means compulsory. Okay, right. Now similarly, just observe this particular column grouping. Here you are having 2 ones. if you don't do this particular grouping, this one was covered by some other grouping. What about this one? For this one, except this grouping, there is no other grouping. So that means this is also essential prime-implicant. Now with this understanding, now just look at this particular grouping. So here you are having two ones. For the timing, if you remove this grouping, this one was covered by different grouping. This one was covered by different grouping. So we will call that one as simply prime-implicant. Okay. I hope it is clear regarding the difference between prime-implicant and essential. Initially, I will call all of them as prime-implicant. If that grouping is compulsory, then I will call it as essential. Otherwise, I will call it as simply prime-implicant. Just like, say for example, when you're having the exam, okay, some of you generally in the exam, few students will qualify, few students will disqualify, right? So that means with the help of result, we will come to know that how many students are passed, how many students are failed, like that. Okay, say for example, you are all BTech students, right? Say for example, one of your friends says that I got the distinction or first class. So that means whether that particular student has passed or not, that particular exam. Yes, obviously passed, right? Qualified. Okay, the moment if anyone says that he got the distinction or first class, that means by default he has passed, right? So in the same way, whenever you are saying one particular product term as essential prime-implicant, by default it is a prime-implicant. That means all the essential prime-implicants by default prime-implicants, but all the prime-implicants need not be essential always. Okay, right. Now in the minimized function, we will write all the essential prime-implicants, and then if any of these essential prime-implicants are not covering any of the ones, then we will consider the other required prime-implicants. So that's why in all the minimized functions, essential prime-implicants are compulsory, mandatory. Okay, if all the ones are covered by these essential prime-implicants, then we won't consider any other prime-implicant. If any of the ones are not covered by these essential prime-implicants, then we will consider required prime-implicants, like that. Okay, so in this example, with the help of this grouping, we have covered these two ones. Okay, and similarly with the help of this grouping, we have covered these two ones. So that means these two product terms are sufficient, right? These two essential are sufficient. So that means the answer for this question is A bar C plus B into C bar. A bar C plus B into C bar. Okay, so this particular grouping is not required. So in that case, we will call this one as redundant prime-implicant. Even if you remove this particular grouping, it is not okay. You will get the same functionality. Okay, so if you recall, say for example, here total you are having three terms, right? So I am just writing all the three terms. A bar C plus B into C bar plus A bar B. See, forget about the K-map. If you are having a function like this, if I ask you to simplify this function without using pen and paper, can you write this function? Can you tell the simplified function is like this? So in order to say like this, which law you are using? Yes, very good, Saptak, Kundan Kumar. Yes, we are using consensus law. So previously I have discussed the consensus law, and now with the help of this example, I have given the proof for consensus law. Okay. Yes, very good, Shubhot sir. Thank you. So that's why I told, whenever you want to do simplification, you are having two approaches. One is with the help of basic rules and laws, you can do the simplification. Another method is with the help of K-map. Ultimately, you will get the same answer. Okay. But based on the given question, sometime with the help of basic rules and laws of Boolean algebra, you can get the simplified function easily. Sometime with the help of K-maps, you can easily solve. Okay. So based on the given question in the GATE exam, you can follow accordingly, right? Yes, Kundan. See, here I will repeat once again what you have to do whenever, especially, see, once if you get the confidence after solving number of questions regarding K-map, in general, you will do this grouping, this grouping. This grouping you won't do, because just by looking at that grouping, that is not at all required, right? That won't come in the final answer. But whenever the question is regarding prime implicants or essential prime implicants, so you have to do all the possible groupings of adjacently placed ones in decreasing powers of 2. In this question, you are able to get grouping of 2 adjacently placed ones. Like that, you are having 3 groupings. Okay, Kundan, is it clear regarding prime implicant and essential? Whatever I have explained, is it clear regarding prime implicant and essential prime implicant, the basic difference? Yes, okay. So initially, whatever the groupings you have done, from all those groupings, whatever the product terms you are getting, initially I will call them as prime implicant. After that, I will check the condition whether that grouping is compulsory or not. Okay, whatever the grouping you have considered, for the timing, if you remove that grouping, this particular one was not covered by any other grouping. So that means this grouping is compulsory. In the same way, with respect to this one, this grouping is compulsory. So whenever that grouping is compulsory, I will rename that particular prime implicant as essential. Okay, and whatever the, if you do this grouping, okay, even if you remove this grouping, these two ones are covered by some other grouping, then I will call initially that one as simply prime implicant. Now in the minimized function, first I will focus all the essential prime implicants. So here I got 2 essential prime implicants. So regarding that, A bar C, B C bar. So here, with the help of this grouping, we covered these 2 ones. With the help of this grouping, we have covered these 2 ones. That means in this K-map, totally you are having 4 ones. All the 4 ones we are able to cover with the help of these 2 essential prime implicants. So that means this particular term is not at all required, because you want to get the minimized function. When you are able to get the minimized function with the help of 2 terms, why unnecessarily one more term, right? So that's why we used to call, in the consensus law, I have told this particular term as what? Redundant term. So the same term I have used here just in front of prime implicant. That is redundant prime implicant. That means even in the absence of, say for example, what is the function here you got, ultimately you will implement with the help of logic gates, right? So this particular term you no need to generate. For this you require one logic gate, AND gate, and then one NOT gate, right? So regarding A bar, here also we require, so obviously we require NOT gate, but we don't require one 2 input NOT gate. 2 input AND gate we don't require. Only 2 input AND gates are sufficient. When you are able to implement one function with the help of 2 AND gates, why unnecessarily one more AND gate? So that is called redundant. Even in the absence of it, if you are able to get the same function, then that particular term is nothing but redundant term. Okay, I hope it is clear. So now let us answer this one. Here we got total number of prime implicants 3, yes, it's correct. Number of essential prime implicants we got 2, yes, correct. Number of redundant prime implicant, yes, we got 1. And number of minimized functions possible, here this 2 is not correct, only 1, right? So that means option A, option B, option C are correct. Option D is not correct. But according to the question, they have asked to identify the incorrect statement. So the answer for this question is option D. So this is very, very important. These are the correct statements. Among A, B, C are the correct statements. Okay, the statement given in D is not correct. That will be the correct option for this question. Okay, so you have to read the question carefully. Based on the context, the answer will be right. Okay, so now let us proceed to the next question. This is the MCQ question. Only one option will be correct. So here also just observe, they are asking the not equivalent. Here in this question they have given one function which is product of max terms, and they have given choices. See, in this question they are not asking the minimized function. Okay, they are just asking not equivalent of the Boolean function. So that means among 4 choices, 3 choices will be equivalent for the given function. 1 choice will be not equivalent, just like the previous question. So you have to focus carefully regarding the terminology. See here, there are two approaches. This question you can solve with the help of K-map, and you can do this. What are the groupings we have discussed? With the help of that, you can observe among these four options which are equivalent, which are not equivalent, like that. That is one approach. So for the timing, I will give different approach, shortcut approach. Okay. So this will be useful for your coming GATE exam. Okay. Whenever you want to solve like these questions, I will give one more approach. See, whatever the given function is there, they have given in product of max term form. Product of max term form. And here just observe, this question is what? MCQ. MCQ means only one option will be correct. Among four choices, one option will be correct. Okay. Now just look at the four choices. Option A is in POS form. Option A is in POS form. Some terms are product together. Whereas option B, option C, option D are in SOP form. SOP form. Okay. So whether we have to do the simplification with respect to max terms or with respect to min terms, that is based on given choices. Okay. See, here majority of choices are what? Majority of choices are having SOP. So that means you have to consider what? Sigma m. Okay. You follow this kind of strategy so that you will get the answer in less time, right? So that is the strategy. Whenever you're having multiple choice question, that means as the name implies, choice is there, alternative is there, right? So try to apply the best method so that you will get the answer quickly. Okay. So for the timing, I'm converting this one into sigma m form. So since it is 4 variable function, for four variable function, the corresponding decimal equivalent you will get 0 to 15. Within this range, other than these combinations, remaining will be min terms. Okay. 0, 1, 2, 3, 4 are present. So I will write remaining terms 5, 6, 7, 8, 9, 10, 11 is present, 12, 13, 14, 15. Okay, I am giving the strategy in order to get the answer quickly. Okay, right. Now we have written sigma m form. Now look at these. Here you are having three choices. Just carefully observe. Here AC bar is there. Here also AC bar is there. Okay, see, there are two approaches whenever you want to solve any question. One method is step by step you will solve and you will come to the correct conclusion point. Okay, another way is you can eliminate the wrong choice also. Okay, based on the convenience. Okay, now I am giving different strategy. So all of you please pay attention. For this question, later in your free time, solve with the help of K-map. You will get the same answer. Okay, but now I am giving different strategy. AC bar is present. BD is present. BC is present. Now pay attention here. Here in this function you are having three terms. In this function you are having four terms, out of which three terms are matching. Now let us verify whether from this whether you can get this one or not. Okay, so here I am considering this particular term AB. A is present here and B is present here. Okay, and here missing variable is what? C, that is present here, normal form, and in its complement form is present here. Now which law we are applying? Once again consensus law. Once again we are applying consensus law, right? So that means even in the absence of this term you will get the same functionality, right? So that means if option B is equivalent, obviously option C is equivalent. See, here the question is what? Not equivalent. Say for example, if here they haven't mentioned minimized function, right? So if option B is not equivalent, obviously option C is also not equivalent. Because it is MCQ, only one option will be correct. Okay, I hope it is clear. So we can eliminate option B and option C are like equivalent. Okay, we can consider option B and option C are like equivalent for the given function. Okay, I hope it is clear. Just by observing these two, and I have applied consensus law. Okay, right. Okay, now let us focus regarding the last one. Here anyway AB is there, here AB is there, here also AB is there, no problem. Okay, now regarding these terms, nowhere it is matching. So now I will write corresponding. Okay, A, B bar, C bar is nothing but 100. Okay, regarding D, it is missing. So that means you will get two combinations. 8 and 9 you will get. 8 and 9, yes, we are having. Next, regarding A bar BD. A bar BD 0, 1, 1. Okay, here C is missing. I will write here 0, 1, 0, 1 or 0, 1, 1, 1. That means here it is 5, here it is 7. So 5 and 7, yes, it is matching regarding min terms. Now focus the last one, 0, 1, 0, 0. 0, 1, 0, 0 is nothing but 4. Whether do you have 4 in the minterms? No. 4 is there in the max term, but not in the minterm. That means this is not equivalent. This is not equivalent, right? So option D is whatever the equation they have given, that is not equivalent. So obviously that will be the correct option for this question. Okay. Similarly, just observe here you are having pi capital M, and this one you can cross check later. Okay, it will satisfy whatever the minterm notation here I have discussed. Similar approach you can apply here also. Whatever the max terms here they have given, it will match. Okay, only the difference is different convention you will follow. Here for variable 1, here variable 1 means we will consider for complement. Okay, variable 0 means normal form, like that, exactly opposite. How many of you liked this question? I haven't used K-map, I haven't done any simplification, but I got the correct answer. How many of you liked this question? Yes, very good Kundan, very good. Is it clear, Saptak? All other students? Yes, very good. Now we are going to solve the next question. That is the last question for today's session. So here in this question they are asking the equivalent. They have given one Boolean function. They are asking the simplified function. All of you try. I am just drawing the K-map only. Yes, very good Kundan, very good. Yes, very good. Others also please try. This is the last question for today's session, and this is the dead easy question. I hope all of you will get the correct answer. So here just place the ones in the respective minterm positions. 0, 1, 1 they have given don't care. Then 2, 3 they have given don't care. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, just place the ones in the respective minterm positions and place the don't cares in the respective positions. Okay, after that, now here if you observe, if you consider these two don't cares as ones, then there is a possibility of doing the grouping of 8 ones like this. 8 ones you can do combinedly grouping. So when you have done combinedly grouping, here row wise b value is 0, that means b bar. Okay, and a value is changing row wise, column wise c d values are changing. So that means when you have done grouping of 8 minterms, you are getting the single literal. Okay, now here if you consider this don't care as 1, now you can do grouping of these 4 ones. Now regarding this column wise, you are getting c bar d. C bar D. So that means you are getting the function as B bar plus C bar D. So that means option D is correct. B bar plus C bar D. Okay. Both the groupings are compulsory. The simplified function is this one. But this question is MSQ because they have mentioned is or are. Okay, MSQ question. So other than ones and don't cares, you put simply zeros. Put simply zeros. Now here you can do the grouping of these 4 zeros. Regarding this, here row wise B value is 1. That means B bar, and column wise C value is 1. That means C bar. B bar plus C bar. Okay. Now here you are having 2 zeros. Here also 2 zeros are there. Combined you can do the grouping of 4 zeros. Then in that case, once again you are getting B value 1. So row wise B bar you will get. Column wise D value is 0. That means D. Okay. So both the groupings are compulsory. So you have to multiply. So B bar plus C bar, B bar plus D. That means option B is correct. So we got option B, option D, both are correct for this question. Okay. So in this way, whichever don't care is helping in order to get the minimized function, we will consider. If you want to get SOP form, we will treat it as 1. In the POS form, we will treat it as 0, like that. Okay. I hope it is clear for everyone. Okay. So with this, we have completed the second chapter. So in the second chapter, we have discussed, thank you, Kundan. So all of you wait for some time. Okay. So in the second chapter, we have discussed regarding the simplification of Boolean functions with the help of basic rules and laws, and we have discussed regarding duality, regarding complement, regarding self-dual also we have discussed, and then we have discussed regarding min terms, max terms, SOP form, POS, or sigma m, pi capital M, etc. We solved a good number of questions, and then we solved the questions related to K-map, and we have done the minimization, and we have done regarding prime implicants, essential prime implicants also. I hope all of you got the clarity. And in one question, without using K-map, without simplifying the given function, from the given choices, I have given the answer, how to identify the correct option, right? Yes. Thanks a lot for everyone for attending this session. Tomorrow we are having the second session. In that session, we will discuss the regarding logic gates and combination circuits. Okay. Thank you everyone for attending this session. Now I will just inform regarding our courses. Okay. Some of you are having inquiries like what are our programs are there in IMS GATE Academy. So regarding that, I will just give one brief. Okay. So all of you stay for 2-3 minutes. Yeah, when you open our website imsindia.com, okay, so here you will be having various courses. From there, GATE mechanical will be there. When you click on that, you will get all the other branches like EC, electrical, IN, CS, mechanical, all the branches you will get. And regarding in our IMS GATE Academy, we are having the programs like classroom program, hybrid classroom, exclusively live online program, and self-learning program. These are the 4 programs available. So in the classroom program, that means in the physical classes, you will be having 750 plus hours of offline classroom sessions. All are offline classes only. And you will get 22 to 30 theory books and exercise books. You are having 4,000 plus practice questions and GATE previous questions. And you are having the access of doubt solving portal, my plan strategic sessions, and test series. We are having 130 plus. You are having chapter test, subject test, multiple subject test, and full length mock test, and then post GATE interview guidance. Okay. And coming to the hybrid, so here we are having same 750 plus hours, but out of which 2/3 will go in the offline mode and 1/3 will go in the online mode. Rest, whatever the features we have discussed, it will be same. And then exclusively live online program. Here all the classes will go in the online session only. Okay, rest everything will be same. And then self-learning program. Here the number of hours. Here you will get the access of recorded lectures of 400 plus hours, and remaining these features will see. And see, whenever you want to prepare any competitive exam, so this is the strategy we used to follow. Okay, see, if you are learning the concepts simply, and if you are not practicing the questions, or if you are not attempting the tests, there is no use. Because when you are learning the concepts, you will feel that you are comfortable, but you will face the problem while you are solving the questions, practicing the questions, right? So that's why this strategy is very important. So we used to follow this sequence. Okay, so first you will learn the concepts with the help of online classes or offline classes based on the program you have selected, and then for practicing you are having our exercise book questions, and then you will attempt all the tests which we are having, right? So you will get the confidence chapter wise, then subject wise, and then advanced subject wise, and then overall all subjects together, right? So these are the various tests we are having. This one, regarding all this we have discussed. So this is the statistics. And then see, the students who are currently targeting for 23 and even for 24 also, all of you are you are having the access to all these courses, okay, at zero cost. You no need to pay even single rupee. Okay, so here in this particular course you will be having access of 100 plus hours of concept videos, and then 12 chapter tests, and then 6 subject tests, 6 previous gate papers. Okay, whatever we have discussed earlier in each program, regarding that some sample set here we will be having. So you are having the access for all this without paying single rupee. Okay, so you can just enroll from our website imsindia.com, then programs, and you select gate branch, and when you click on gate branch, this particular web page will come. There zero fees program will be there. So you just click on enroll. So it is very much useful for all of you. So those who are preparing for 23, so you also can have access of this one, and you can tell about this information to your juniors also, so that they also will have the access of all this, right, for free of cost. Okay, and regarding student portal, you will be having the access of courses like this for online program, and then you are having the access of LMS doubts portal. This is a very, very important feature which we are having. Okay, see, in general, when you are attending the classes, whatever the doubts you are getting, in general you will ask in the class, so that those doubts will be clarified. But when you are practicing the questions or when you are attempting the tests, that time if you are getting any question, in general in our India there is no institute is providing such kind of access with the help of faculties, between faculties and students. Okay, there is no doubt solving portal access direct. Okay, but here you are having the access of doubt solving portal. Okay, so whatever the doubts you are having, you can select the particular subject, and you can, whatever the screenshot of the question is there, you can just screenshot and post here. Within 24 hours our faculty team will resolve your doubt. Okay, that is one of the most excellent feature which we are having. And then one more important feature, this is my plan session. This particular activity is also no institute is providing. See, in general in the class, whatever the students having the doubts, they used to have the discussion with the faculty, but some students are having the fear, or like they may not interact with the faculty. Okay, they may having the fear. Okay, so but here we are having one portal access, my plan session. Here you are having one-to-one. Okay, one student can interact with the faculty, and wherever you are facing the difficulty regarding your preparation, if you want any guidance or whatever the subject doubts you are having, so you can get it resolved with the respective faculty, and even one-to-many sessions also there. So this is one of the most important feature that we are having. Okay, so this is about regarding our programs. So I have given brief about all our programs, so that you can share this knowledge with your friends, juniors, etc., so that those who are interested, even without paying single rupee, you can enroll for zero fee program, right? Okay, I hope all of you liked today's session. So all of you kindly share this video link with all of your friends, and please inform that tomorrow we are having the second session regarding digital circuit subject, and in tomorrow's session we will discuss the questions related to logic gates and combination circuits. All of you kindly revise logic gates and combination circuits, and please attend the session sharply at 6 o'clock. Okay. So all of you, please share your experience regarding our today's session, and we'll end today's session. Okay. So all of you, kindly share your experience in the chat. Yeah, thank you, Saptak. Good night. All others also, please respond. Please share your experience regarding today's session. Yeah, thank you, Abhilash. Thank you, Saptak. Thank you, Kundan. Thank you all the students who are attended today's session. So kindly attend tomorrow's session sharply at 6 o'clock. So we'll meet you all on tomorrow. Okay. Thank you, everyone. Take care. Good night.